the keynote speaker of this experimental IoT village. Thank you for giving me this opportunity. It's quite late here in Moscow. Everyone is sleeping now. And I'm broadcasting from our hackerspace called Neuron. You can see it on my background. It's the first Russian hackerspace located in the very center of Moscow. 5 minutes walk from the Red Square and Kremlin and Mr. Putin. And if you are going to visit Moscow, I invite you all to here. You can find it simply by Googling Moscow Hackspace. So today we'll talk about my hardware project. It's called the Flipper Zero, as you probably know. Here it is. Here's how it looks like. It's on the remain. Flipper is the open source multi-tool device for pen testers, researchers, and hardware hackers. It's the Swiss Army knife for access control systems, radio protocols, and so on. But it's not just a piece of hardware. It has a personality of a curious cyber dolphin who enjoy hacking all kind of real physical systems around it. Here's how it looks like. You'll probably see. Flipper's character was inspired by Dolphin from the old cyberpunk movie Johnny Mnemonic. He was a cybernetically enhanced dolphin who used its ultrasonic waves to hack stuff around and burn bad guys. Here is this, if you see the slides. Here it is, how it looks like. Very excited. So what actually Flipper Zero is? Before answering this question, I want to tell about how I came to this idea. And last few years,
these devices are being adopted for deployment.
Pen testing physical access control system. Here's on the picture you see the schematic of one of my projects. It's a versatile dual access control system that supports many types of RFID tags as identifiers, such as EMV bank cards, like Apple Pay, Google Pay, and Moscow Troika card at the same time on one reader. So we don't need to issue and manage our cards. User can choose whatever card he already owns. This system is implemented in our hackerspace right now, and it's very handy and I'm very proud of it. It's controlled via Telegram Messenger chatbot from the web interface, and very cool. If you will be in Moscow, came to see it. And as a developer, by the way, sorry for Russian signs on this picture. As a developer and pen tester, you always have to build your own hardware tools. Usually, it's a naked PCB with some shields stuck on it, and a bunch of wires, and all of this mounted on the breadboard. And it looks like this. Usually, you all know. And here's the picture how I'm going to the bank with the Proxmark to sniffing and pen testing some bank terminals. The security is mad about this. And here is the picture of the Hydra Bus NFC tool. Hydra Bus with the Hydra NFC shield on it, taped on the power bank. It's a pretty good tool for sniffing ISO 14443 protocols. And it looks like a sandwich of PCB with antenna, and I had to mount it like this and tape around the power bank because it's breaking apart, and you can't put this device in your backpack, can't put it in your pocket because it's all scratched, breaks. And this problem usually face it with anyone face it when making their own tools. Once I made a custom NFC reader based on quite popular chip NXP PN532, which is only exist in naked PCB, and it had to be robust enough to survive in my backpack. So I filled it with the epoxy resin. You can see it on the picture, and here's the real this device survived after so many years. It's completely waterproof and robust epoxy resin. It's looks some dirty, but it's very, very robust. This is my first attempt to make my own designed device with third-party PCBs. Also, I like to play a Tamagotchi, the old school toy from Japan, and I make some silly modification, soldering the T5577 chip into the Tamagotchi that have ability to communicate with other Tamagotchi on the 125 kilohertz protocol. So I made a Tamagotchi that opens my doors. It's very funny. And once ago, I saw a Semi's cam car. You all probably know the Semi. It's a famous guy. I see the project called Open Sesame. Semitake kit toy. It's a pager, probably, I don't know. It's a very old toy for kids to chat between several of these devices on the very small radius. And upload the custom firmware to weaponize this device to open garage doors. He found a way to modify the firmware and upload it and make a well-built tool in a real consumer product. Yeah, and when I saw this, I liked this idea so much because I always use these dirty PCBs that scratch my pockets, that every time breaks. And when I see it, I think it's so cool, so amazing. No need to soldering and use the tape or so on. And when I'm playing with modified Tamagotchi, I feel the same. It's very, very cool. So after all, I saw the project called Pionagotchi. It's like a Tamagotchi, but instead of food, he eats the Wi-Fi passwords and the hashes. This device made it by Evil Socket, who also make a project called I forget. It's like a Metasploit framework for network attacks. So after using all this device, I wanted to make a well-designed, pretty robust and fun, robust device in nice case that combine all necessary tools for daily pen testing, for access control system, radio protocols, and so on. So let's see what is actually Flipper Zero. Right now, I'm taking the it's a prototypes. One of the prototypes we built to test our features. It's already have a manufactured case, but it's not a final look. You can see the drilled holes, and it's a CNC made case. And take a look of features of Flipper Zero. So first of all, it's completely open source. You can modify the firmware, upload whatever you want, and modify it as you want. Flipper has a monochrome display, like an old school phones, like a Siemens, Nokia. Because this display is ultra low power, so we can put Flipper in always on mode. You don't need to turn off and turn on like you always do with your phones. It's always on display, and when we turn off the backlight, you can still see it on the screen, and it can work in this mode almost a week probably. I'm not sure about power consumption right now, but it's quite long. Here you can see the some specifications. Let's take a look at features. First of all, I want to make it work with IoT sensors, garage doors, car locks, doorbells, and so many gadgets that work on free non-licensed range, like 433 megahertz and several different, like 168 megahertz in the different countries. So we put in Flipper the CC1101 chip that can both transmit and receive any kind of digital modulated signals. So Flipper can work with all this stuff. It's a customizable platform. You can use whatever modulation you need, like FSK, ASK, and OOK. But the problem is the antenna that is tuned to one specific range. But we try to to make it work on the wide range of frequencies to suitable in any country. So Flipper can analyze the radio protocols such as key lock. They can sniff it and then print on the screen the parsed protocols. So you can, if you find the unknown key fob, you can just press on the button and see what frequency and what protocol it works. Also, Flipper have a 125 kilohertz RFID tag support. They can read, so you can lay in the card and read the ID. You can save it in the memory, and then you can easily emulate this card from the memory. So you can save unlimited list of different tags cards from your office, from your home, and emulate it anytime. You even can enter it manually. So you can ask your friend of the ID of his card, enter it on the Flipper, and emulate card. So you don't need even a physical card. It's a quite difficult part because there are a lot of protocols on this frequency, like a HeatProx, EM4100, and so on. They use different modulation types, but we working on it now. Right now, Flipper can only read and emulate EM4100 protocols. So here, how it looks like. Flipper also have the old school infrared transceiver. So you can control your TV, your air conditioner, to turn off any TV that's annoying in the bar or something. You can also learn the new type of remotes just by put it on the flipper and entering in learning feature and save in memory some keys on your remote. Flipper also compatible with Platform IO. If you know, it's a extension for the Microsoft Visual Studio Code. So you can write your own code and upload it into Flipper. Not like regular Arduino boards when you upload the only one firmware at the moment. So every time you need a different feature, you need to re-upload it, reflashing completely. In Flipper, you can upload your code as a plugins. So you can go to plugin menu and choose whatever code you upload. So no need to refresh every time you need a different program. So you can extend it with your own plugins. Flipper also have, if you see this GPIO holes, I don't know if you see it or not. Here it is. It's a GPIO holes, so you can put your PLS wires in it and connect it to the different hardware, like flashing your Wi-Fi router connected to some industrial devices via SPI, UART, I2C, etc. And use it as a bridge via USB to any kind of industrial protocols. And instead of Arduino or Raspberry Pi board, the Flipper is completely autonomous. So it have its own, here is its own 3 and 5 volts power. So you can power devices from the Flipper. You can use the API of the display buttons and vibration motor and piezo speaker to control it from your own programs. And you can see the debug message on the screen while you connect it to some devices. You don't even need the PC for this. Flipper based on the STM32 chip. It's very popular, and this chip is quite powerful, so you can implement on it the custom USB stack to use it as a bad USB device. You probably know the USB rubber ducky, and there's many tools like this. So you can simulate on the Flipper the heat device, like a keyboard, to enter the custom payload on the PC. So when you connect it to the PC, they connect it as the keyboard and type whatever you want. And since Flipper have the display, you can choose whatever payload you want. You don't need to just hardware switches like on Rubber Ducky. You can choose from the big library of payloads. It can be the Ethernet adapter with the poisoned evil DNS, or it can be a keyboard or serial port. No matter. And it also have the I button. I don't know if other rest of the world know what is I button, but I button, it's a contact keys like this, very popular here in Russia and in Belarus and probably some Asian country. I don't know about the USA. It's contacted keys, worked on one wire protocol. And Flipper has a, I don't know how to extend it. Yeah, we have a custom built iButton connector because the flipper can both be as a reader and as an emulator of the one-wire key. So you can emulate this, read this key, save it, and then emulate on the real door. The flipper, I want to talk about how we start development on flipper. First of all, I think about the shield for the Raspberry Pi Zero as a Peonagotchi. But since we start developing, we face it with some difficulties because the Raspberry Pi is quite old platform and it not have enough, it's very power hungry, not have enough options like sleep mode. And after all this failure with Raspberry Pi Zero, we think about developing our board from scratch. This project was separate from the Flipper Zero into Flipper One. This is under hardware development project. Right now, it's not even the prototype part. Here it is. It's a completely Linux-based computer, like Raspberry Pi, Orange Pi, and so on, based on NXP IMX6 processor, ULZ series. This is a very low power device, low power processor that is even don't have a graphical core, so it's much more effective in power than a Raspberry Pi, and it will work on the Kali Linux. Write it directly on the SD card. Because the Flipper Zero is only based on the STM microcontroller, you can boot it with Linux. Now the Flipper One is the more advanced device than the Flipper Zero. It will have all features from the Flipper Zero with power of the Linux. The same bad USB mode. The one feature of the Raspberry Pi, why we dropped the Raspberry Pi support, because the quite old and buggy Wi-Fi chipset, because it works only on 2.4 gigahertz and don't support the modern 5G network that spreading the coronavirus. So we can't spread the COVID virus with the only 2.4 gigahertz, so we need the 5G. And we start looking at modern chipset for the Wi-Fi hacking. This is a quite difficult topic because there is no modern chipset that support both the packet injection and the monitor mode. So we now researching, and I invite everyone who know the good chip that work over the SDIO, not over the USB interface, because for embedded devices we need the SDIO because of low power and much better support on the processor. So I invite you to go to our forum and suggest your variants of good Wi-Fi chipset that support all hacking features. And also Flipper One will support the NFC that is not supported by the Flipper Zero. NFC is another big topic because we want to make it completely emulate complete cards with the UID and so on, and a lot of chips on the market don't support this with the libNFC and so on. So we are looking for the best NFC chipset, and you can suggest your variants on the forum. And probably my time is over. Am I right? Or no?
Hey.
Yeah. So if you want to talk more about Flipper, you can go to Discord. I will answer to any of your questions. Thank you. We are planning to start on the Kickstarter in the few weeks, probably when we finish our paperworks and the legal part and the company bank accounts and so on, and we start the Kickstarter company. So enjoy and join to us.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, a medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, a lot of hackers work in these small groups. They don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide.
They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.
So I'm going to give a talk, basically take you back in time to some of you who are at ages 30 or 40 will remember this time. Back in the weird 80s, there were lots of strange 8-bit computers that everybody created to do some of these. Now these are a lot quite UK centric, so some of them you might not recognise. So there were machines like the BBC Micro, the Commodore 64, which is popular in the US, the ZX Spectrum, the Oric. So some of you in the US might remember TRS-80, TI-9948. There are also consoles like the Sega, the Mega Drive, the Nintendo Master-Com, or the Famicom as the US call it, and the PlayStation. Of course, my parents didn't buy me any of those. They bought something called the Sharp MZ700, which was useless. Yeah. But in the past few years, people have been going, oh, we remember those computers. They were really good. So other companies have gone out and they've tried to repay them to try and get on this retro nostalgia trip and basically give people a chance to play the old games. And then they realise they're rubbish. So these re-image consoles are just basically left behind and never used again. So one thing, just before I originally wrote this slide came up on Twitter, which just to show you, when we talk retro, Xbox 360 is now officially retro. That's quite a scary thing. So anyway, I'm going to talk about two. So let me restart. Went out and bought a couple of these. So there's in the top left you'll see what's called the ZX Vega, which is basically a Spectrum. The Mini C64. Now there's recently come out a Maxi C64, but I couldn't get hold of one. And a PlayStation Classic. Now two of these I will tear down. This sort of came out about a conversation which I had with a friend about what was running on that ZX Vega. And how was this meant to work? So they can't be connected to the internet. There is no technical security risk, but the techniques to go through to find out this sort of thing are really what we've been using when we do an assessment of something. So let's start with the ZX Vega. So the first thing you do is just try and make an assumption. How's it running? So if I was to write this, I'd do a basic Linux system, and I would put run the largest spectrum emulator called Fuse on it, and then I've just run away, a sort of visual interface. So I've got a bit of a video. I want to sort of demonstrate how it works. So wait for Google to cache. So this is it. At this point, I've only got a circuit board, so it might be a bit slow when I videoed this because I'm using a pair of tweezers to sort of press the buttons. As you can see, it's quite a bit very old school in the 80s. I'm just loading up a game here just to see how easy it is to play. And yeah, I'm not really very good at that game. So one of the other facilities that this has is you can load custom code into it. So it's got an SD card and you can put on a Spectrum Snap and put on an SD card. So when I first presented this was the P-size lids, and I built my own little demo. So anyway, let's leave that up behind. So when we look at some hardware, basic routes we can go. We can look at the hardware, and we can look at the software that runs on it. And all of these may present avenues for attack. So I'm going to start off with the firmware, which is my favorite thing in the world, which is hex dumps. And you better really like hex dumps because there's quite a few of these. So when you're looking at this, the first immediate thing that springs out to mind is this massive string here, where we can see a version number, we can see a data release, and we can see basically a copyright string. If we go a bit further into the detail itself, we can try and break out the actual binary and the hexes above that. We can see a magic number. We can see that date that we see below 2015, September, 9th of September 2015, and we can see that version number. The information around it, we can see a file size, and then we've got some rough padding bytes. So in C, that's a sort of rough C structure that we can sort of work out about the header. Then it goes on to a second header, which is basically an SPI configuration block, which is describing the data sheet for the actual CPU point inside the device itself. There's not really much that we can get from that, so we can safely ignore most of it. Then we have another block behind that, which we can actually then, that's a standard block for the MCU that's in place, which is an AXB IMX. So we can then look deep into that, and there's a program that I managed to find called SB Tool, which would allow me to dump it. So I've dumped the header there. There's one important thing that comes from that. It's an encrypted image. So basically, can't get any further with doing this. So let's have a look at the hardware. This is the front of the board. There are three things that sort of pop out. There's the MCU, which is an IMX233. So it's an ARM core device that can do, it's actually a really powerful chip for what it is. It can basically do all the audio, all the monitor stuff, and control everything. We have DRAM, which is basically system memory, system RAM. And we have SPI flash memory, which is long-term storage for the device. On the back side, the only thing that we've really got of interest, we can see loads of buttons, and we've got these three sets of pads here, which could be all various different interesting things. So, first thing to do is to try and read out that data. Now, Flash ROM failed to work on it. It failed to identify that flash chip. So, I've talked about SPI before, and SPI flash is quite a common technique to see, and you can basically read it from Python. So the program we're using there is called SPI, and it's a Python script that I wrote, which I can just read stuff. And then there's a sort of one-click web interface I did to try and read it. I sort of munged the script a bit to get it to work, but eventually I could read it out. And it's exactly the same as found in the firmware, so it's encrypted. That's not going to get me very far. So next step, let's have a look at the hardware. So we can see those pads are interested. So the first thing we can do now is to use a multimeter and continuity mode to try and buzz things out. So we know from the front side that some of these pins are in the top header are ground and some of them are positive 5 volts. So we can buzz those out. So the ground pins I've just highlighted in black. And they're easy enough to find and to see where sort of grounds are. And the reds, you can see it, but there's one at the top header as well, and that's positive 5 volts. Let's go into it. Let's have a look at junction 4, J4, sorry, and we can mark out the earth, the ground, sorry, and then we can mark out and we can find out which pin it is by running the multimedia continuity mode, and we find out we've got TX and RX for UART, which is a UART port. That's generally quite good. J3, the one on the left goes to ground through a capacitor, so that's why it won't buzz out to ground, but it eventually goes to ground. Second one is called an SJTAG debug line. So SJTAG is a 1-pin JTAG port, which is a very complicated and proprietary protocol. So I have to, you need adaptable to use this, and it's quite rare to actually find them. And the other one is just basically voltage reference. So if we look at the junction J5 at the top, so if we mark these out, we can see that should look familiar already. It looks very similar to a micro USB port. So we can sort of make a guess of how that works. And we can sort of say, look at familiar. So we can see 5 and 1 are ground plus 5 volts. 4 is the identification pin, which is basically either floating or ground, which tells you whether it's a host or a device. And the other 2 are USB DP and DN for data plus and data minus. So we can then try and buzz those out, and hey presto, we buzz those out to be a USB port. So this is all the ports mapped out, and I'm hoping you can see that. So the next thing to do is to try and actually solder some wires to this and to actually attempt to view it. So first thing we go is for the UART port. Now those people in the UK who've used the BBC Micro would recognise that screen, it's very familiar. So that's basically a bit of a joke. It's not really very much helpful. I can't get a shell on there. What I can get is error messages, which was very useful later on. So we can't do anything with that one. Let's go to the next one. Let's go to that USB header. Now I apologise for the photography here. I just moved house and I haven't unpacked my microscope. So this is all done on my iPhone camera. So I rigged up a sort of basically a sort of debug board to allow me to actually connect across. So there's a sort of complicated, that's using an SJ-tag adapter board through an Olimex OCD device to connect to the board itself. Oh, sorry. Let me go back. I didn't get anything from that one. It didn't enumerate. All I could get was power. So then the next final one is the JTAG, the SJ-tag board, which is where I'm using an adapter board which is proprietary technology, and I can't find any details about it, so I have to use their board through an Olimex OCD device, which then connects to the board itself. At this point, I'll just show you my desk at this time, because I've got a fully populated USB hub there where I'm monitoring everything from the device itself. What you can't see is under the desk is a Velcro USB hub, which is providing power to all the different boards I'm using to get this image. Because it doesn't produce HDMI output, I have to also use an AV converter to view this in a monitor. Quite a lot of USB going on there. Anyway, running through the SJ-tag, using OCD, I can connect directly to it. That is what you'd see in a successful connection. So I'm using the Olimex ARM USB interface, and I'm connecting to an IMX233. I can now then connect, I can hold CPU, and I can see what looks like information in the registers. The important one here is if you look at register 15, which is the process counter, I get a valid address. That is in the RAM allocation for the chip, so I know that it's roughly valid. So next thing to do is look at the memory map on the datasheet for the IMX233. So we can see then tests that we can read. We can read from on-chip SRAM, which is basically the secure bootloader. Again, it's a familiar string, and also what we're seeing here is ARM code. So that EA on the top nibble of the 4th octet generally is the ARM code for always. So that means that the instructions always run. So it's a very quick way of working out 32-bit ARM, is look at every 4th byte, is that octet, that is the top nibble, an E. So going into the on-chip ROM, we can read that. Now, it's a bit more bootloaded, so when it boots up, it takes the on-chip ROM and it will read through that. It's exactly what I'd expect on IMX233, but I found a rather strange message in there. So apparently no pygmies were harmed during this testing. Not certain why that is there, but that's standard for the IMX. So next one is the external DRAM. So this is actual RAM. And as you can see, this is the area where PC is based. So we're actually getting proper 32-bit ARM code here. I can't dump ROM easily because the IMX uses a method of paging ROM in and out, and you have to do a bit. You have to basically pull data in, decrypt it. I could have done it if I spent enough time, but you know, by this point I'd had better things to do. So I just basically made the assumption. So if I'm running an emulator, then if I start again, that emulator should be paged into RAM, and I should be able to dump RAM, and then you look for artifacts that look like an emulator. So, we see at the top is the first few bytes of the Spectrum ROM, which I've taken from the general emulator online. So if I can find that in the memory, then I can know that an emulator is running. I can pretty much say that it's paged in. So I ran it, paused the memory, and then dumped it, and hey presto, at that address, which I'm not going to try and read out because it's quite long, is the Spectrum, is basically the Spectrum ROM. So I know that I've got an emulator, I know that the Spectrum ROM's paged in, so that I know that the data's paged in. I looked for artifacts for Fuse, which is the most common emulator, and I could not find any. It's unfortunate, but there were no strings and nothing to highlight that Fuse has been run. So I can't really guarantee for that. So the last thing to look at is that software. First off, simple attacks. Can I do a few shell breakouts? And no, I can't, which I would suggest that they either neutralize everything or they run on raw iron. There's not an operating system there. I'm looking at the other things from the RAM, the operating system isn't there. So there is one avenue left to attack, which is the emulator itself. So let's go back into time. This is a die of a Z80 microprocessor. I stole it from online. There's a lot of information about this inside it. I'm specifically looking here at in the bottom right corner. Those are the registers for the Z80. So this is going back in time a bit. The Z80 is basically a machine code compatible version of the Intel 8080 with a few extensions. So let's talk about some registers. I'm going to race through this one because it's not really that exciting. There are a set of 8-bit registers that can be combined into 16 bits, so A, F, B, C, D, E, H, L. There's a duplicate set of those that can be swapped in and out. Index registers, which are for indexing stuff in memory. Program counter, an interrupt register, and finally something called WZ, which is used as a temporary store buffer. So because Z80 is only 8-bit, it can't store 16 bits easily. So what it does is it loads it into the WZ register, and in theory you can't ever access that from machine code, except there's a book. And certain instructions, like the bit NHL instruction, will leak out bits of WZ. So this is sort of interesting because in the mid-2000s, before we mapped out the Z80 properly, WZ was not known about. The way that this worked in the back end wasn't quite certain, so many emulators, including Fuse, fudged it and always returned one, either all bits high or all bits low. In about 2010-ish, it was discovered and a lot of emulators were updated. So any emulator that was written since 2010 roughly will understand the WZ and show the instructions and show the behavior of understanding the WZ register. Anything before won't. I will sort of race through here. So I wrote a bit of code. This is a bit of Z80 code that will basically load a value into WZ, set it to a known value, do the instruction that will leave memory in it, and the rest of it is just getting the information back. So I put this in the Spectrum basic program, which took bloody ages to type in an emulator, and then run it. This is what would happen on ZXSpectrum.net, which supports WZ. I get all passes. If I run this on Fuse, well, an old version of Fuse now supports it, but there's a sort of, that was 2018, I think that change happened. It fails. So there are proper test suites that do this properly, and I chose one called Raxoff. This is a whole range of tests. So the Spectrum.net passes it. If I run it on the Vega, it all fails. So to me, this tells me that this is an emulator that does not support WZ. So it is most likely the core refuse, but I can't prove it. So I've literally got 5 minutes left, so I'm going to have to race a bit further. On to the C64 Mini. So this came up from the same people who did the ZX Vega, but for a different company. It's actually a totally different board, and it's done in a totally different way. So let's have a quick look at the firmware. Anybody who's doing any reverse engineering can see immediately there's an ELF header, and that byte 28 says that it's ARM code. You can see basically file offset, so we can see how big the file is. And I didn't sort of twig this until I started actually writing the slide that says AC64, AC64. There's a load more file offset stuff as we go through, and there's basically some chunk data that goes through. Now, if we load this into Kikra, we can actually start decompiling. So there's no debugging information, but what they have left in are strings. And as any reverse engineer will tell you, we like strings. They give us clues and tell us about stuff. So in this case, we can see basically telling us that gcry cipher set IP failed, which tells us that they're using the gcrypt, which is basically where that function's used. So if I expand, so a bit of mangling around, we can see that if I change the function names a bit to sort of mess up, I can see where it is actually setting up the encryption to decrypt the rest of that file. So we've got cipher open, a setting key, and a set IP. So that is the code where it sets the key. Now what that's doing is messing around with emptiness. That's decompile code. I'm not quite certain what it does, and I can reverse it, but it'll take a long time. So what a cheaty way of doing this is, let's just run the executable and then use something like GDB to interrupt it and actually see what the key is. So I don't have an ARM device that I can use. I could probably use a Raspberry Pi, but I'll be honest, it's easy to use something called QEMU. Now QEMU is it's a system emulator which can emulate a number of different CPUs. But one of the nice features is you can run you can run an executable in QEMU in a sandbox on your own machine, whatever it is, and then you can attach DPV directly to it. So this is basically what I'm going to do. So I'm looking for this init cipher function, which is at this address, and I'm looking for those two parameters that have been passed to it, R2 and R3, which are the key in the IP. So here's a video of me actually running all this in one go. I will apologise, there are typing errors in this. It's really, I had to redo this video about 4 times. So I'm using QEMU to load it up in the single step mode so that it will start pause. And I'm telling it to start GDB on that process. Start off GDB, and I'm connecting across to it. Set a breakpoint so that it dumps me back in control when it gets to a cipher. And then run the program, and now it's reached that breakpoint, so I can just dump the registers. So this is dumping register 2. I don't normally type that slow, by the way. Dumping register 3, so you can see I've got the key and I've got the IP. So that's useful. I could decompile it from there, but also at this point, I did a Google search, which I should have really done at the start. I found out that people have already found a UART port on it, which is sort of there on it. I'd already soldered the header to it by this point, I got a bit carried away. There's also 2 buttons which allow you to get into the file mode, which is basically the bootloader. So if I run this, it gets me through to a command prompt, a login prompt, and importantly, there's a hit any key to start auto boot. So let's rerun that, and we press the key on boot, and we're into the bootloader. So we can actually see that that is a command that it runs. We can change that so that the bootloader and then boot from ramfs, which means to get to a shell prompt. From shell prompt, we can cat etc shadow. I haven't been able to crack that password. But what we can do is we can change that password. But then we get into a shell, and with 1 minute to go, that's the end of the presentation.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, the medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer, and by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, a lot of hackers work in these small groups. They don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.
Thanks everyone for taking time out of their stranded schedules at home and not going anywhere to actually watch my presentation. So as Sam mentioned, a look at IoT device interchip communication. What this presentation is about, it's kind of a focus on looking at communication as it flows between chips on a circuit board, and some very specific stuff that we started out as this project that we're going to actually talk about today. Again, my name is Daryl Highland, research lead for IoT at Rapid7. Been doing this crazy stuff for 25 plus years. So why am I doing this research? Why are we going down this? What's the whole purpose of this thing? The big thing is I wanted to really start getting an understanding of what end-to-end is when we're looking at IoT technology. You know, because we can look at all of the components, all the data, the cloud services, the communication, but what happens when data hits that circuit board? Is there stuff that we can glean from that? Can we learn from that? Can we figure, you know, the functionality, security, a better idea of what that ecosystem is? And the why is to identify attack vectors eventually. This presentation, we're not going to talk about any specific attack vectors that have been found or identified, but we're going to talk about the concepts around some of those. Improve product testing methods. By thinking about IoT interchip communication analysis, can we add more steps, more capability into our toolbox around testing product technology? Can we use this to potentially identify vulnerabilities? And also, can we use what I'm showing today, the concepts today, to potentially weaponize a product, to use it to attack other things? So the target focus on this research initially, like I said, was interchip communication. But the main part starting off is looking at Bluetooth low energy devices and non-routable protocols. So as an example, if you have a piece of IoT technology that's running Bluetooth low energy and you want to control it from the internet, you have to bridge that technology to the internet. So you start looking at bridging technology. Now, bridging technology will tie the Ethernet side, Wi-Fi side in to the Bluetooth side to give you that full ecosystem and control from the cloud. So in that case, we want to be able to look at the communication as it's flowing across that circuit board to get a better understanding of the threat vectors. Because if we have a piece of technology that has fairly good security, let's say they're doing the Bluetooth low energy right, they're encrypting the communication out of the back end of the device to the cloud. So at that point, we really can't see a whole lot or get insight into it. But if we start looking at the data that's flowing between processors on the actual bridging technology, at this point, we're potentially looking at technology or data that isn't encrypted in any way. It is the raw data to tell this device to do A, B, or C, or whatever it was designed to do. So the goal of the presentation is, in this research, is to dig into that and look at methods, methodologies, and such. So one of the things I mentioned is looking at the interchip communication. Now, there's two general scenarios we see when we look at these bridging technologies. Well, there's literally three, but there's two that we use for testing. The one we wouldn't use for testing, it would be the primary processor, the microcontroller unit would be both BLE, Wi-Fi, and Ethernet. So it's kind of hard to see interchip data communication when there's no other chips other than the primary CPU. But in the two that I often encounter the majority of the time fall in these two categories here. It has a BLE, a Bluetooth Low Energy microcontroller, and a Wi-Fi microcontroller or an Ethernet some type of network microcontroller. The other one has multiple microcontrollers, and it would be like a BLE. It would have a main microcontroller, and then it would have the network circuitry or network MCU associated with that, or it could contain other microcontrollers that are all overall managed by the main microcontroller unit on the device there. In that case there, these are the communication paths we want to be able to tap into to see what's going on. So getting started, to be able to tap into this and start looking at it, you have to be able to find the circuits on the board. So how do we go about doing that? So the first thing is reverse engineering the circuit board. Literally, let's map out the circuit board. That would include pulling down data sheets. It may involve using a multimeter to ring out connections from point A to point B. A lot of visual. The background on this screenshot is actually a circuit board that we literally took all the components off of it, stripped it bare as an example, as a test unit, to actually map out the entire circuit board and kind of reverse engineer it to get a better layout of what was going on. Also, Damien Coquille did a presentation, Hack in Paris. And one of the things he did in that presentation was dealing with photo overlay. So taking photo overlays of both sides of the board and making them translucent and laying them over each other to kind of map out both sides of the circuit board into a visual with the vias passing through. Another option would be X-ray. If you want to go to the extreme level and you have access to X-ray and you're dealing with multi-layer boards where it may be critical to be able to look at all the different layers that are actually in the board. So again, you want to be able to reverse engineer the circuit board, understand what's on the board, how they're all interconnected, and that's the only way you'll eventually be able to tap into the right circuit and be able to analyze the communications. So the first device we want to look at happened to be a smart lock called Hickory. Hickory Smart. Is put out by Hickory. So let's go and dig into that. So this is its general layout. It has a BLE microcontroller. It had a main microcontroller, and then it had a separate Ethernet circuitry involved in this. And our goal is to look at BLE to main MCU and look at that communication. When dealing with BLE, it's a simple form of communication. It's UART, universal asynchronous receive and transmit. I have not run across a BLE chip that uses anything but that for receiving communications from another processor and for receiving command structures from other processors. So on this particular device, this is kind of open the device up, start taking a look at it. It had a SRU 532, which I kind of remember the name of the company. Started with a D, Dynamic or something like that was the name of the company. And under the hood of this particular Bluetooth low energy module was just an NRF 51422. The main processor on this was an LPC 1778, which is an ARM Cortex M3. This particular board's layout was way more simpler than a number that we run into. So as we dug into the board and start looking at it, we pulled the data sheets down, figure out how each one of these components, the Bluetooth low energy module, was laid out and pinned out. We also looked at how the ARM Cortex processor was actually pinned out and what pins were used for what in this particular case. I think with the ARM Cortex, this one was a general GPIO, so it wasn't tagged as typical transmit receive, if I remember correctly, or it was potentially multiple. So we had to trace it back from the actual Bluetooth low energy device. And this is kind of here us tracing this out. As we can see, the green runs all the way to from pin 69 on the primary microcontroller to actually pin 6 on the module. The yellow line, which is receive over to the transmit line, which is on the other side of the one device, actually passes through the board as a via, and we can see with a larger yellow line there. So at this point, we want to be able to, in this project, be able to do a number of different things. We want to be able to capture the data and look at it. We want to be able to sever the communication between these two devices so they can't see each other as part of some of the testing. We also want to be able to inject data into the UART circuit. And this is an end-to-end circuit with no components in between it. To be able to inject data into this with some kind of UART tool, the line has to be severed. If you try to inject into these connected lines, it won't work. If you run into a circuit that actually has like resistors in line with it as kind of a terminating or impedance matching type circuitry, often you can inject data into those without cutting the lines. But the ultimate goal is to be able to tap into this, cut the runs, and route all the communication off the board onto a breakout board for further analysis and testing. So here we can see where we've attached the red leads or red arrows actually show the connections for transmit to receive, receive to transmit between the two components. The green marks are marks on the circuit board where I actually took a razor knife and cut the circuit board runs. So at this point, everything has to leave the board. And I built these small breakout boards. I have probably 3 or 4 of these that I've built. It gives me the ability to use the screw terminals to land the wires. And we also have headers so we can hook multiple pieces of test equipment, whether you want to hook an O-scope up, a logic analyzer, or some other kind of tools, serial communication tools to this. And we have a on and off dip switch, gives us the ability to literally turn the circuit on and off as needed if we want to capture and replay data onto the circuit, or actually inject our own fuzzing data into the circuit. So when it's all said, this is kind of how it's rigged up. This is probably one of the first ones that I did. We have over to the left, those are 2 Shikras where we're using the UART communications on those to tap in. And of course, Saleae logic analyzer to initially kind of map out the communication and figure out its baud rate, how many bytes are in each standard packet to kind of identify that whole structure and format there. So this is how it was all laid out. Right now, I actually have, instead of using the Shikras, I have a 4-way serial device that I hook everything up to. But I continue to use these breakout boards like I have showed here. These things are very useful, and they come in really handy. I have one sitting in a desk right beside me, and one over on my workbench right now with stuff hooked up on it that I'm actually working on. So let's keep going with this. So let's look at the communication on this particular device, get an idea of looking at this. What are we seeing? How do we potentially decode it? Again, this is kind of the layout. We have a lock device, which is believed to be Bluetooth low energy. You'll see something interesting here in a minute. We have a bridge device, which is where we want to tap into the interchip communication, and then the cloud-based services. And this, and I can't overemphasize, if we're in the center of this, that gives us a lot of capabilities. We could potentially, in testing, be able to inject data from the bridge device to the lock device, or potentially send data back out to the cloud from this test point also. So we went ahead and we hooked up to the circuit we had showed in that one picture, and we captured the data. We captured opening the lock and closing the lock. And from there, we can make some general analysis here. We see that the beginning of the communication starts out with a 2D, 2376 BD. I mean, there's so much that is identical up until you get about 1/3 of the way through and hit a 3.9 or 3E. So at this point, how do we identify this? And what these components are. Also, it's also important, this is where a logic analyzer comes in. If you're just capturing UART, when you're capturing processor to processor communication, there's no end-of-line characters or carriage returns. So it's just going to continue streaming data. So using a logic analyzer, you can figure out where the packets start, where they begin, and identify the potential beginning and ending terminators of the communication data that's going through. So this is what it all decoded into. The 2D 2.3 was basically a frame header. We go clear to the end. We had a 8-bit checksum to complement. And in between, we had some various other pieces of information. Some we were able to identify, some we weren't. To start with, the device ANT SN. Often when we're looking at communication going from a main processor to a BLE chip in this type of environment, we'll most often see the MAC address in that communication. In this communication, there was no MAC address. It turned out by looking at other stuff on the chip, actually pulling firmware on the chip and taking a look to try to see what they were doing, it was determined they were using a protocol called ANT. This kind of took me back. I wasn't expecting it. This particular NRF processor is capable of Bluetooth Low Energy and ANT communication. If you were communicating to this device with a mobile phone directly to the lock, it was using BLE. The bridge was the only one using ANT protocol. So it's very BLE-like, but ANT protocol you often see used in fitness bands and heart rate monitors for sharing this data. This particular type of protocol has a number of different security mechanisms that are interesting. It allows multiple pairing. Unlike BLE, multiple devices can actually be authenticated to the device at the same time, which is very interesting. It also has multiple pairing functions or features, and I have them listed here. Everything from exclusion, white blacklist, proximity search, wildcard. So there's 6 different type of pairing structures that can be created. Some of them with low security, some of them with high security. I don't remember which one off the top of my head that they were using here, but it was obviously the more higher security pairing process. So now we go back and we look at the communication on this thing, and we also find out it has ANT protocol. We also analyzed, and we'll show this in a minute how we did this, that the bridge device to the cloud was using MQTT as part of its communication. This was determined by looking at that main processor actually had a UART console. So we hooked onto the UART console and we're able to see it carry out the MQTT communications. When we're also looking at that console, it turned out that all the data coming from the cloud and to the cloud was encrypted. MQTT was all encrypted, but the console, debug console on the microprocessor dumped the full decode of the packet out there. And from this data here, it helped us further analyze that communication to the BLE chip and identify what it was. We were able to identify op type. It shows op type here, and that is 1 and 2. 1 is open and 2 is a close, I believe. We also see the device ANT serial number. This is like a MAC address, but this is what's used by ANT communication protocol. We also had a key down here that happened to be base 64, and right above that there's op params, which is a base 64 encoded block. If we decode that, all it spells out is operation parameters. So it's a holding spot that isn't currently being used. So we wanted to be able to check to see if this key was the actual key that was being transmitted from the main processor to the BLE device. So we took the base 64 using a standard echo command base 64 hex dump, and we compared it to the communication going out to the actual BLE chip from the main processors, and we can see it's the same. Now, obviously, the 2 bytes are reverse ordered, so C2 2C is 2C C2 in the output there, but it is the exact same key that's actually being used. So that's how we're able to identify the key. So we have the frame header, the device ANT serial number, which is like a MAC address, op type, tells it to open, close. We weren't able to identify the first unknown, the 03 or the 05, but we also identified that there is a 4-byte op time, which is like the standard Linux timestamp. And then we had the key and then the actual checksum. So we're able to take this and start experimenting with it at that time. So what did we do? Initially, we just tried to replay this. What happens if we replay this at the chip level? and we turned out that this key never expires. It always works. I've come in 4 months later and replayed something I captured 4 months ago, and it works. So what does this tell us when we start looking at these devices? One, this one was interesting because of that AMP protocol. It took me off my edge. Wasn't expecting that. The keys never expire. So also, since the keys never expire and every packet coming in from the cloud or every request coming in from the cloud has a different key, what is this key made of? What is used to construct this key? And how does the Bluetooth or BLE device know if the key is correct or not? Remember, these devices are unaware of each other, unroutable protocol, and we're using the bridge to route the communication. So there has to be what's known as a shared secret. So the shared secret in this particular case happens to be when the device, the Bluetooth lock device, is actually configured. It has a little barcode on it. You enter that data, that's communicated up to the cloud, and now they have a shared secret. Since it's rotating constantly, how does it calculate that and how does it change? Because it'd have to have another thing to actually identify that. And we believe it actually is the timestamp. We believe the timestamp is some type of salt to the encryption, which is constantly changing a known shared secret. So it gives us some insight on how this device is communicating, how its end-to-end security is working. And of course, moving forward, it opens up more opportunities. So how can we do fuzzing attacks against this? How can we do other testing to this thing? Can we trick the device? Can we figure out what the shared secret is external to the device? How well is that actually protected in all the communication? Because if we have the shared secret, we can potentially get the timestamp and potentially be able to identify a key or generate our own key that would actually work as an attack vector. So the second device we looked at here actually is a Brelong. I don't have it marked here, but it's a Brelong, but we're not discussing any known vulnerabilities with it, just how the device is functioning and the same kind of concepts. In this particular case, there is no main CPU. It's a Wi-Fi MCU and a BLE MCU. So this is how the device is actually laid out and configured in this particular environment. So in this case here, we have the Wi-Fi actually is an Expressive, which we already know Expressives have a number of their own issues. And then we have the BLE module up here, which is specifically built by this manufacturer. And we blow this up and we start looking at where the transmit receives are. We can see in this particular circuit, there is actually a small resistor in line in the communication path. And I know I had mentioned this earlier. So at this point, we want to do the same thing. We want to be able to tap into the circuit, route all the communication off to a breakout board so we can better do our analysis and testing in this particular device. So if we look at how we're going to tap into this, we find out that to tap into a circuit like this, you need to be on the transmit side of that resistor. If you're on the other side of that resistor, I've noticed it caused some kind of impedance loading issues that were kind of weird between the two devices, and it impeded the communication or halted the communication in a number of times. But if we did it on the transmit side, we were fine. So if we're going to tap two wires in and cut the runs and do it on the transmit side, we're a little bit in trouble here because that's probably only, 3 or 4 or 5 millimeters of space to be able to do all that and isn't really practical. So as we gave this some thought on how to do this, it was like, well, why don't we just move that resistor to somewhere else on the board? It'll still accomplish the same thing. So that's what we did. We kind of flipped the board over. And we can see that all that communication coming off the BLE was actually routed through 2 vias and over to the Wi-Fi card in this particular case. So what we did was we removed that resistor. and we switched over to the other side. We ended up cutting the run, soldering it up, and actually soldering the resistor onto that side. And then we were able to just connect our 2 wires to the other side of the board where the resistor once was to break that circuit, and then cut the other run right below it and be able to tap into that down that side to be able to give us the level of connectivity and routing the communication off to our test board. As you can see, my breakout board is designed a little different. I've been trying a number of different designs to see which one are easier to work with. But here we are. We went ahead and tapped into this device. There's probably a few extra wires hooked onto that board because I was doing some other weird stuff with it too. We brought it over to this to be able to do our breakout with and analyze the communication. So let's go ahead and look at the interchip communication on device number 2. So we went ahead, similar to the other one, we went ahead and captured basically an open and a close. We also captured, showing in this picture, the actual return data. So we have BLE receive data and BLE transmit data that went over to the Wi-Fi chip. The transmit data went over the Wi-Fi chip was in 2 blocks of data. The one was saying, hey, I did the command. The second one was generally telling it the status after the command was executed. So if we look at above that, the BLE receive, the open and the close, we can literally see that this packet, other than the second byte and the last byte, never changes. Ever in this particular case. We started analyzing this, and we also found out that the actual MAC address wasn't in the transmit packet. This kind of confused us. There's an 8-byte block of data there, turned out to be actually encoded. So they took 6 bytes and encoded it into 8 bytes, which I have no idea why. So how do we figure out that that was the actual block that they were encoding? I did this through some general fuzzing because what happens is the returned data coming back from the BLE microcontroller to the Wi-Fi microcontroller actually contains the MAC address, which is extremely strange. You would encode it one way and not the other way. I'm not sure the mindset there, but this is generally what it looked like. So we sent an open command, we got the 2 commands back, and we're able to receive this MAC address. We started fuzzing each one of the bytes up there being injected into it, and we found out that if we alter any of those 8 bytes, we actually were able to change the MAC address. And we noticed that any of the bytes had to be changed by 2 bits or 2 characters. If we didn't, it would actually not return anything. So if we look at this, what I did was I went through, this is just a small sample, where we went through altering these in a fuzzing attempt and building a table. I didn't have the time, so I reached out to a number of the coworkers at Rapid7 and go, hey, here's a fascinating puzzle. If anyone's interested in digging into this puzzle to see what it looks like. And Pierce was able to jump in there, and he took this data, converted it into binary, and started mapping it all out, and was able to figure out generally what they were doing here, to the point where he was able to create a coding decoding tool, making it possible for me to, if I wanted a MAC address, particular encoding mechanism, I could do it, and I could use that for various fuzzing. I don't show it in any details here, but the other 1, 2, 3, 4, 5, 6, 7, 8 bytes that come after that, we weren't able to figure out what those were completely. We believe those were some kind of key, but we started fuzzing these. And we found out the last 2 bytes, the 9-8 to D6, that we're able to fuzz those to a point and not prevent the lock from actually rotating, which was very interesting. Means that the potential key space is much smaller that they used to generate this key with. At this point, we ain't figured out what that is, but it's on the radar screen to circle back around on these and continue doing some kind of testing, injections, and fuzzing. So we also, in this particular case, went a little bit further. This particular bridge device will only pair with one lock. So if you have two locks, then you have to have two bridges, which is strange. But we wanted to figure out how the bridge devices were programmed. So we captured them during the setup and configuration. So the first one is to remove the bridge from the lock setup. And it run these 3 packets, hit it, which basically removed it from the system. What it actually did was, if we look at the bytes starting with the, we have 4 bytes over, it goes BC, CC, C2, A0, 1C. If we take that 8 bytes there, like we're on the other screen, that is the encoding, and we run this through a decoder, it's basically setting all of the MAC address to all zeros, is what this actually did. And then we walked through and we added the bridge back in, the legitimate bridge with the legitimate MAC address, or adding the device back into the bridge. All these packets were the same other than the second byte, which kind of defines some kind of command structure. And the last 8 bytes on the last one. And by replaying this data, we did a couple tests. One, I tried removing the lock and adding another lock using this mechanism, and that worked. I was able to add another lock to the device, remove the old one, add another lock, just by injecting my data at the chip level. Then we went back and I said, well, what happens if I don't remove the bridge, the lock, and I just add a new lock? And I did that, and we had some really strange occurrences, because for about 30 minutes after injecting this into the actual BLE chip, I was able to control 2 separate locks from the same bridge by interjecting at the chip level. What does that mean? I'm not sure, but it opened up a number of potential further testing and attack points that we're going to need to look at kind of moving forward. So, observations of end-to-end security. In this particular case, it was BLE pairing. The MAC address was encoded, which is kind of strange. It was encoded in one direction, not the other. This particular one had the same key. It was the exact same key over and over and over. So just want to point that out. So if we look here again, we see the only difference in the open and close shown on this page here is the 00 versus the 01. So literally the exact same key. So there isn't anything about, hey, test this 6 months down the road and see if it expires. It's never going to expire. It's never going to change. It's always going to be the same key. So that opens up interesting ideas about the potential security related to this device. Encoding from a common shared secret. Like the other one, which had what appeared to be a shared secret and also the timestamp potentially used to generate it. This one did not have that. So there's some kind of encoding taking place against some shared secret, which again, I believe it is the initial setup code for the BLE device. When you register it in the cloud, that would be the shared secret. So then it starts us thinking, how safe is that shared secret? Is there other ways to pull it off the device? Are there other attack methods? The communication to the cloud services, does it secure that shared secret or the device identifier that's used to generate that shared secret effectively? And these are things that actually need to be considered going forward. So, last thing we want to do is kind of finish up here with some of the testing processes, implementing methods to my madness, and give these some thoughts. So one of the things we want to do, and what we showed today, is kind of the process of tapping into the interchip communication for analysis. It's the process of mapping out the boards, the process of tapping into the boards, rerouting traffic off the boards. We want to be able to move forward by doing this and build testing methodologies around replay. Can we carry out testing functionality and do replays? Can we map out communication paths and functions effectively? Can we validate true end-to-end security? I mean, as we look at what we've done with this so far, at the limited level we have so far, we've identified basically how the keying mechanisms work. We haven't solved the encoding or encryption methods that they may be using, but we know what they're doing. We know potentially what those breakpoints are. It gives us target areas to look at. Also from the replay standpoint, you know, can these replay attacks be generated externally? If we look at a device and we can figure out this attack method from an internal standpoint, can that be extrapolated out and carried out externally against the device if we know certain things about that device or those type of devices communications? We want to be able to validate that whole end-to-end security, the data flow, the security, and really get our mind around those concepts. And this plays a big part in ongoing security testing and testing methodologies. We want to get into injection attacks and fuzzing. We used fuzzing in this particular example to figure out or start figuring out how that key structure is laid out, or we actually identified that a portion of that was the actual MAC address. By looking at the data that was echoed back on this particular device and its encoding, we were able to fuzz that out. What about the key? We haven't done the fuzzing on that, but what if we did? What would be the impact of that? Is there things that we could do to cause adverse reaction in the system? Is there a master key? Is there something I could fuzz into this device that it would go, hey, and give up the ghost and roll the lock? We don't know. These are some kind of fuzzing and injection attacks we want to be able to open up to these environments for further testing. We have the ability to do this in both directions, cloud and target. As an example, we've seen the data coming back from the BLE device to the bridge, to the microcontroller. What's that data used for? Often that data coming back from the device is status data. So that status data can change what's happening on your mobile application. And I actually tested that. I did some replay of communication and altered it and was able to make the mobile application change status, saying the lock was open when it was closed, or saying it was closed when it was open, by injecting at this particular level. Now, how does that impact someone else's lock? It doesn't. It just gives us an idea of how the communication works and opens up further ideas and concepts around testing, injection, replay, and actually fuzzing-based attacks. We want to check for fault conditions. Can we, and I've done some of these, can I send keys of all zeros or all Fs and cause a reset or a crash? In the cases that I did here, no. That did not work, but that doesn't mean there isn't something that would have adverse effect on how the device functions. And some of this stuff plays in big further as I talk about some of the other concepts around what we want to do. And one of the things is weaponizing the bridge technology. If I can go out and buy a device, a Bluetooth low energy device that has a bridge, I can tap into the interchip communication on that bridge, map all of the end-to-end security from the cloud to the device out, figuring out how it works, can then, from inside my device, reprogram it to turn it into a weapon to attack someone else's device. That's what potentially interests me. Once you figure out how the device works, can I weaponize it? What does that mean if we actually do that? So we got a future here. What is that future? What do we got planned next? I had some of the stuff, I talked about this last year. Some of the things got delayed a little bit, but we're starting to move forward on some of those. I'm working on a white paper. I actually got 1 page of it put together. The goal is to have it done by Q3, and it's to cover these concepts, methodologies around this. We're also working on a tool, kind of a UART proxy. Hopefully we'll have something available by Q3, Q4 this year. And the goal of the tool is we can take a device, we can tap into it, cut the runs, route the data off of it into this tool, and be able to do man-in-the-middle fuzzing, replay type communication testing on the internal circuits of an actual board within its functioning IoT ecosystem actual environment. We do have some basic tools that I started writing up, and I like horribly suck as a programmer and very slow. I actually have 2 other guys from Rapid7 that are helping me out with this, and they're looking at some other stuff. Right now we're doing some stuff in Python. The ultimate goal is this initial release will probably have some kind of tool that will be more of a command line, similar to the stuff that I've personally written and put together, but with more features and functions. And then the ultimate goal will be to be able to have a graphic user interface of some type to be able to see the data, analyze the data, and carry out various type of testing like fuzzing, man-in-the-middle, and replay style attacks. So I think we're at 40 minutes on this, and I think that pretty much finishes up what I have. Again, hopefully you guys enjoyed this. We're covering, in this case here, we covered, reverse engineering the boards, tapping into the boards, utilizing design breakout boards, looking at the data, using what's available to analyze that data and decode it, and then working around fuzzing and replay to try to figure out how the end-to-end security of the technology works. So I hope you enjoyed this. I'm going to be jumping over into the other channel as soon as we're done here. And if you have any questions, kind of meet me over there, and hopefully I can answer those for you.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, the medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference. If these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, a lot of hackers work in these small groups. They don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.
Excellent. Thank you so much, Sam. I really appreciate this opportunity. Sam mentioned I'm one of the co-founders and chief technology officer here at Refirm Labs. And hopefully you guys can learn a little bit today about analysis of real-time operating systems, specifically analysis of the ECOS operating system. And just a little backstory on sort of how this talk came to be. We were, as probably many people on the stream realize, is that there was a vulnerability released about in January that affected pretty much every single cable modem almost in existence, right? Pretty much every cable modem based on the Broadcom chipset. And so we kind of wanted a way to automate the identification of that using just the firmware image itself. So there was some existing capability to identify this vulnerability by active network interrogation, but we're a firmware analysis company, so we wanted to take a different approach, sort of get more to the ground truth. So I have a few slides, and then we'll just jump into Ghidra and take a look at some disassembly. So just a little bit of background on ECOS. Depending on how much firmware you've looked at from a vulnerability analysis point of view, you may be familiar with it, you may not be familiar with it, but it's an example of a real-time operating system. And basically what that means is you traditionally when you're doing vulnerability analysis, you have either like an ELF file or a PE file, and this file tells you, hey, we have code here, we have data here, my CPU architecture is this. But in RTOS land, you sort of get none of that, right? You get a flat memory model, right? You can kind of think of it as everything on the device is running in kernel space, right? There's no user space, kernel space separation. There's no context switching. There's no moving pages back and forth. You only operate in that kernel space. And there's benefits and detriments to that, right? The benefit of running solely in kernel space is you have direct access to the hardware. You can do things very quickly. And the benefit of real-time operating system is that you can do real-time operations, right? You don't have to worry about potentially getting context switched when you're in the middle of a critical operation. But the detriment is that you really don't take advantage of any of the sort of modern security mitigations that have been around in the last decade, right? You generally don't get stack protection. You generally don't get sort of no execute pages, things of that nature. And so when a vulnerability, especially a remote code execution vulnerability, pops up inside of an RTOS, you have full unfettered control over that device, right? So it's a very dangerous set of circumstances that would lead you to be able to control, like in this case it's a cable modem, but you can this stuff is being used in industrial control and other medical device fields and things that are much more sort of life critical. And so from a vulnerability analyst point of view, we need to answer a few questions. We need to, well, first we need a firmware image, right, to do that analysis on. And we need to figure out what the CPU type is. And sometimes that's really obvious and sometimes it's really not. We need to figure out where the load address is for that firmware image, right? A lot of people, when they first start doing analysis on real-time operating systems, they assume that the RTOS is going to be loaded at sort of the CPU initial instruction address, right? So MIPS and ARM, they have a fairly standardized set of addresses that they're going to start execution at. However, even in this small embedded RTOS world, we still have a bootloader involved, right? And the bootloader is generally there to recover an image in case of a bad flash, but it's also responsible for finding the image of the RTOS and loading it at a specific address and jumping to it. And so there is no, while each RTOS themselves have a standard load address you can generally rely on, generally that changes between RTOSes and even between CPU architectures within single RTOS. And then you also need to figure out, because this is one large monolithic kernel, we need to be able to figure out where code starts, where code ends, where data starts, and where data ends. Because we don't want our disassembler to be interpreting data as code or code as data, right? And in this specific case, because we're dealing with a MIPS device, we need to be able to figure out what the global pointer register value is. And that allows us to make more intelligent decisions on how these long, far calls might be being made. It's also useful to look at the cable haunt vulnerability itself. So these are just snippets taken from the report that was published on cablehaunt.com. But you can see the vulnerability is pretty straightforward. You put a malicious buffer in a parameter called fstart hz or fstart hertz, and it causes a buffer overflow. And so you can see that the cable modem is implementing a spectrum analyzer web interface that was designed for the carrier to be able to detect like poor signal quality and other signal impediments on CPE equipment or user premise equipment. And it was never intended for example, for end users to access this, right? But it was all implemented in WebSocket API calls with JSON back and forth, right? So it's a very sort of modern web technology being implemented in an RTOS that was first implemented 21 years ago, right? And so that's sort of wrought with peril, right? Like if you took a traditional Linux developer and told them that you were gonna parse user data in JSON format in the kernel, they'd probably look at you kind of strangely. And so that's exactly what's happening here, right? You have these JSON blobs going back and forth from effectively kernel space on this device. And so when this bug came out, we went to our nearest Best Buy, and we picked up the cheapest cable modem that we could find there. Right, I think it was like $100. And it comes, it's DOCSIS 3.0. It works on Comcast and Charter and all these other networks, right? And so we went down the path of, can we tell our users if cable haunt is affected in this particular firmware image, right? And so the first thing we did, we took the device home, we took it apart, right? We didn't even turn it on, and we connected our C232 FTDI cable to the UART on the board, and lo and behold, we turn it on and we see all sorts of useful stuff, right? So the most important thing we saw was that in the image in the bottom left here, which tells us the exact load address that the ECOS image is being loaded at. It also tells us that the ECOS image is 14.5 megabytes, which is just crazy big for an RTOS image, in my opinion. But we also got, and it's not shown here, but we also got a full Linux command line interface, right? So we knew that there was ECOS on this device because we see it in the boot log, right? But yet we're getting a Linux prompt when the device fully boots up. And so as it turns out, there's two effectively firmwares running on this device. There's an entire ECOS subsystem, which is just for the cable modem itself, and then the Linux subsystem, which is what like the end user would interact with, like setting your DHCP settings and things of that nature. You'd be interacting with the Linux side. And so you have a Linux router, wireless access point, things like that, and then you have the modem. And there's a very sort of good reason why those two distinct things are separate, right? Because in the cable operator world, the cable operators are the one that have complete control over the image that runs on the cable modem itself, right? So if either you rent a device from your provider or you buy one at like Best Buy, for example, you plug it into the cable provider network, they are the ones that control the firmware that's running on the consumer premise equipment or the actual cable modem. And so they're able to push updates, they can change configs, they can do effectively whatever they want to that end user's modem. And so keeping the Linux subsystem, which is sort of like the user control part, and the ECOS subsystem, which is sort of like the carrier control part separate, is actually a pretty good design. But the downside is that you can't just go to like manufacturer websites, grab a firmware and see what's inside that ECOS image because it's all controlled by the carrier. So what we were able to do, because we can't get access to that firmware image by just downloading the firmware for the device, what we did is we got the shell into the Linux subsystem. We figured out how to fire up a Telnet daemon and then exfil the firmware by effectively DDing the MTD block device that stored the ECOS firmware image. Right? So now we have the load address for the RTOS, right? We have the firmware image itself. You can see that in the bottom right, Binwalk is telling us that it's MIPS, which means it's not MIPS EL, so that means it's going to be MIPS big endian. So, I've been using IDA for probably 15 years now. So, I'm very comfortable with it. So my next step would logically be, hey, let's throw this into IDA, right? But loading RTOSes in IDA is kind of wrought with peril, right? So you tell IDA, hey, we have a MIPS big endian system. You tell IDA, hey, we have this load address where the image is being loaded, but the result is that we get no cross references, right? So IDA is easily able to identify like function boundaries. It's easily able to traverse the code tree and find new functions and find cross references between those functions. But the data cross references just don't work, right? And that's what we want to find. We want to find where the vulnerability is within this firmware. And so loading an RTOS in IDA in reality involves defining the CPU architecture, defining the load address, doing some disassembly manually, right, to identify what the global pointer value is, telling IDA what the global pointer value should be, then doing some more manual analysis to say, where does my code end and where does my data start? Then tell IDA where code ends and data starts. Then going to the interweb and finding a GitHub repo from Craig Hefner saying, this is with the Codatify plugin that allows you to fix up the data section to define strings and words and things of that nature. And then turn on auto analysis and then wait, a few minutes, and you might get cross references that you're interested in, right? So in this case, this is an example. We went through the process of loading into IDA, but at the end of the day, you're still stuck with, disassembly, right? And there's no symbols in this particular firmware image. So you're stuck with identifying leaf functions and then trying to name them just by looking at MIPS disassembly. So we decided to take a different path and just try out Ghidra. It's the brand new hotness everyone is getting on board with. So let's see how Ghidra handles RTOS loading. So we have we just tell Ghidra, hey, we have a MIPS big ending 32-bit CPU. We tell it, here's your base address. Now let's see, I'm gonna pop Ghidra hopefully into the screen here. And this is what we get, right? Now, granted, I didn't load it live for you on this video because it takes like probably 15 minutes to load this 14 meg image into Ghidra. But the sort of most important thing is that we can go into our defined strings window here, right? We can look for our parameter that we're interested in finding the overflow for, double click it, and we see instantly we have one cross-reference, right? So we can click on that, go to our decompiler, and instantly we can sort of see the vulnerability. Now, I cheated a little bit, right? Because I took the firmware image from that was released as part of the disclosure document and was able to name functions, right? So I took the other image, I think it was a Technicolor device. I took that ECOS image, and based on the report, I was able to name certain functions, and then I created a function ID database, right? So I created my own custom, I called it cablehunt@FIDB. But what this allowed us to do is when we loaded this image, we got the string, the functions named for us right off the bat, right? And so when you look at this now, right, the vulnerability is fairly obvious, right? Especially looking at the decompilation. We have our fstart Hertz string here. We have a call to stir. ivar1 is likely that JSON blob that's being sent in the WebSocket. And we check to see if we have a value, right? And if we do have a value, we look for 0x2c's comma, right? So we're looking for a comma within after ivar2 inside of the ivar1 blob. And then we use strncopy, right? And when I first saw this, I was like, well, they're using strncopy. Like, why is this an overflow? Until you realize that they're passing the wrong size into strncopy. They're effectively taking the length between the end of fstart Hertz and the beginning of that comma and passing that to strncopy. So even though we have a 24-byte stack variable here, it doesn't matter. The length of that variable is completely ignored, and we have it. This is where the overflow is. And so and then they take that value, convert it to an integer, and use that as ivar8, right? But what's interesting is that we can see that the same exact parsing logic is used for fstop Hertz and FFT size and num of samples. And so I haven't verified this, but I can pretty much almost guarantee that there's an overflow in every single one of these variables. And so what we really want to demonstrate here is that the time it took to go from extraction of the firmware image to being able to identify and then automate the detection of this cable hunt within an ECOS image was greatly accelerated based on the fact of how Ghidra is able to automatically identify the string cross-references and the demarcation between data and code, as well as the just being able to look at decompilation, right? And so because you can look, I actually checked out the CVS from the CVS repository. You can go to the ECOS website and you can check out their full source code repository using CVS, which I haven't used since 2005. And when you look at that code, you can actually almost line for line make a correlation between these library functions and the original C source code. It's actually that good, right? So identifying those leaf functions, those library functions, should be fairly straightforward using the ECOS published source code from 11 years ago as a good reference, which is good and bad. It's good because there's source code that we can look at to try and identify the API calls, right? But it's bad that the code hasn't changed that much in 11 years that it's pretty easily identifiable. One other interesting thing I just want to demonstrate is that this isn't the only real use of stern copying in this image, right? So you can go here and you can look, and there's Guido's not working. Oh, here we go. So there's 71 other uses of strn copying. Similarly, there's 63 references just to plain old, good old fashioned stir copy. So I guess the lesson here that we kind of want to convey is don't parse JSON manually in kernel space, and try to maybe try different tooling. If you're used to using IDA Pro, give Guido a shot and see what it can do. It certainly surprised me, and it might surprise you as well. That's all I have for today. Thank you so much for listening. I did finish a bit early. If you guys want to maybe pop some questions into Discord, I'm happy to discuss this further with you guys.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, because we have a really talented team internally, but we can be educated by people. It's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, a medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, a lot of hackers work in these small groups. They don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.
Thank you so much. And let me just say how excited I am to be again with the IoT Village. I've been doing this at DEF CON. It's not as fun as having all of you in the room, but I do hope we're going to have fun 40 minutes. It's going to be a fast ride because I was, moving around and Sam tracked me down. So hang tight. And with that, usually what I do is I start with a direct question because I'm Israeli, and I ask the people in the room whether they know this guy, and then I have some hands coming up, and I can't see you all, but I will still ask, and some of you might know, this individual, Kevin Fenster. So he is a respected security researcher, white hat, really, doing some great work in security. And a while ago, he was interested in doing security research on an embedded device. Some of you might call it an IoT device. Definitely connected in things, drones. And he found a vulnerability that at the time, according to the reports, generally had some issues in one of DJI products, and he wanted to report the vulnerability to DJI. They launched a bug bounty program actually at the time for their products, and then launched it with this, media appearance. And according to the reports, he was really interested to learn whether the vulnerability he found was in scope, because there were questions around the scope of the program, because there was this launch, but no really website with detailed about the scope in terms of exactly the products, exactly the issues. But he wanted to do the right thing and report a vulnerability. So he contacted DJI, according to the reports. And, you know, in the communication, they told him this vulnerability is in fact in scope. And, you know, it's an interesting vulnerability. How about $30,000? So for those of you bug hunters and security researchers that are, you know, with us in the room, this is, you know, a pretty substantial bounty. He in fact at that time started to negotiate with them, according to the reports, around issues of disclosure. And again, we didn't really have that detailed website with all the details around, you know, the scope and authorization and disclosure and the contractual terms. It was more of a statement, and there were questions, and then in negotiations, you know, again, according to the reports, turns out that the parties were not able to agree about some issues, and he decided to basically disclose this issue, disclose his experience on Twitter. He described a draft legal letter that mentioned the Computer Fraud and Abuse Act, which is a federal anti-hacking law that was in part as part of this communication sent to him. And it turned down the $30,000 bounty, decided not to take the bounty, according to the reports. And, you know, there are a few sides to the story. DJI also have a statement about this story. By the way, they changed their bug bounty. And if I recall now, they do have now a safe harbor and an explicit authorization in their scope. So it was kind of, I guess, a learning opportunity, because they have a kind of a more general bug bounty now terms, and you can check that out. But I think what this tells us, you know, he decided not to take the $30,000. There was some conversation, according to reports, according to this draft letter, the CFAA was mentioned. I think what we're seeing is a growing kind of understanding that we're going to need to collaborate, all of us together in the ecosystem between the security research community and companies. There is desire to introduce bug bounties and vulnerability disclosure programs. There is desire to facilitate bridges and collaborations, but there is some legal nuance. There are some questions. There are some learning opportunities. And I think this is just a kind of a case study on how the law can interact with something that all of you are engaged in every day, kind of in your daily course of business, which is security research. So I tell this story, by the way, because I think, you know, it's important to share, to have this dialogue between people that are doing security policy and people that are doing hacking, ethical hacking and research, and really have this discourse between the technologists and the engineers and the people that are engaging in policy making and are operating in this area of the legal realm. So I'm Amit. I'm going to tell you just very fast about myself. You know, I moved from Tel Aviv. You can hear my accent, my Israeli accent, to Sunny, California, to do my doctoral degree in the law, focusing on technology at UC Berkeley. I still teach there in the Master in School of Information. I joined Intel. I do security policy work for Intel. And I was really very fascinated about issues around contracts and intellectual property and computer crime and privacy. And this is what I studied at Intel, among others. And my sister, you might know her, Karen Lalzari, she has a very, very famous TED Talk on hackers as the immune system of the internet. She told me a lot about anti-hacking and hackers. It got me kind of interested, and I started to kind of look at how the fine print can actually support or prevent research, and that is how I came to study those issues. And I've been talking a lot, also, you know, with this community, sharing a lot in conferences on basically how can we work closer to build bridges to kind of connect ethical hackers and companies. And actually, I have a few disclosed bugs of my own. I'm a proud kind of not alone by myself, with my co-authors from Berkeley. My prior work, I got bounties from Facebook and Google. So I kind of have been in all sides of the equation. And really, this is the real issue. You know, technology and law are evolving together, and we're seeing policies and laws impacting technology more and more, and technology impacting law and policies more and more. So we need that kind of discourse. And really at Intel, part of my work is really at looking at cutting edge, where we can build trusted foundations and we can connect those dots. I'm full disclosure and disclaimer. So as you heard, I am a lawyer. I'm trained as a lawyer, practice law in Israel, but I am not your lawyer. Everything that I'm going to talk today is basically my own opinion. I'm going to share a lot about my prior work, and I'm not going to be providing any legal advice, as I often explain on my talks. So we have really seen a growing kind of trend of security and privacy policies. Those of you who are listening right now probably are familiar with either GDPR, right, in Europe, or CCPA, our recent privacy law in California. There is a growing body of laws in privacy and security, and it's definitely an evolving landscape. What is very interesting is it's evolving also on the front of the anti-hacking laws and unauthorized access and bug bounties, and I'm going to talk about that. On the front of vulnerability disclosure policies and programs and handling processes. And so this is the whole process that talks about how we can receive reports about vulnerabilities from external researchers and how we handle them internally and how we work towards a mitigation, test it in different environments and release it. But it's also specifically booming and really evolving in the area of IoT, connected devices security. And I'm going to really talk to you today about this whole evolving landscape. We'll share with you some of the most recent trends. This is not going to be an exhaustive overview. We can't cover all jurisdictions and all issues, but I hope to give you just a taste, so you would be interested in engaging in this kind of discourse and learning more about these issues. So one of the key concepts that is definitely evolving is this issues of having reasonable security practices at place. If reasonable sounds vague to you in the room, this is a broader thing that we have in law and policy and technology, which is we have a principle-based approach. So you would see terms like reasonable, because the idea is that technology evolves really fast, and the law needs to have the flexibility to evolve with it, instead of having a specific design, which might be, or a specific concept, which might be true for one area, but not, as the laws stay the same and technology evolves. We now have passwords. We can think about a future in which we're not just going to have passwords, but a variety of authentication means. So this is just an example of kind of the principle-based approach. Now, this concept of reasonable security practices, which is also a body of law, a notion that the Federal Trade Commission, the consumer kind of protection regulator in the United States, is pursuing, has been evolving with technology. And one of the interesting things is that the FTC is becoming very technology savvy. So they have engineers, they have people that actually investigate the technology, and their cases are becoming more and more kind of technology savvy, looking at different environments, not just production environment, but also non-production environment. Including this interesting case that involved Uber. One of the interesting things that if you open up the decision, you will see that as part of the settlement with the FTC, Uber is actually agreeing to continue and maintain the bug bounty specifically for as part of the settlement. So you can see both the kind of security issues that are arising, the technical complexity, but also that this decision to some extent, empowers the bug bounty team to continue and maintain the bug bounty. And it's an interesting tie to kind of the broader lens that we're going to talk about, which is together with this evolution of IoT security and privacy regulation, we are seeing a specific trend around quote vulnerability disclosure. In fact, there are two cases in which the FTC has alleged, together with many, many, many other things, because this concept of reasonable security is definitely very complex. But as one element, they have alleged that the idea of having a process to receive and address security vulnerability reports from external sources like security researchers like you and academics, if you don't have that process together in many, many other things, they have alleged that that might be a violation of the FTC Act. So isn't that interesting? And we are seeing definitely a lot more kind of government bodies. Recently, we have seen a binding operative directive in draft released by CISA DHS proposing that all federal agencies should have this kind of process processes of vulnerability disclosure. So this is definitely a trend that we are seeing in this landscape. And I will share in a minute, it actually connects very closely to IoT in specifically. So what's really, what's kind of the take, or what's kind of the most interesting part, I think, for the security and ethical hacking community, is that we know that there is, the landscape is evolving. There is this need for collaboration, and we all understand it. And the community is doing more and more research, external research on embedded devices, on IoT. But we also know that we have in the landscape the anti-hacking laws, and these are still, there are questions around it. And according to surveys that were conducted, researchers have reported that anti-hacking laws might be a consideration they think about on whether they will report or not a vulnerability. So this is a very interesting survey. One of them, the fourth bullet that was conducted by, actually it's NTIA. What they found, not this, NTIA, what they found is more than 400 researchers, they asked the question, and 60%, 60, that's pretty high. If you think about it, that's hundreds of researchers said that the threat of legal action was a consideration on whether they're going to work with a vendor to disclose. So they already found an issue. They're sitting on this issue. They have the report. Now they're thinking, am I going to report it or not? And legal action, this culture of legal action comes to their mind. And it's not the issue of whether it's actually being enforced and being used. We all know that, there is a very big collaboration with the security community, and there are many safe harbors and protections for researchers right now in bug bounties. But it's this culture that we are working towards through collaboration to see how we can handle. We also know that communication in this regard, just the kind of communication between companies and researchers is also a big consideration in terms of whether the researcher is going to work in court and vulnerability disclosure. And from a legal landscape, this is a very interesting question because we have a lot of laws operating here. I'm not going to go way too much into the details, but there is a relationship between the different anti-hacking laws because the key issue, and these are just the main federal one, the Computer Fraud and Abuse Act and the Digital Millennium Copyright Act, the key, both these laws, and there are state laws as well, really hinge upon the notion of authorization, as I'm going to explain. And authorization and consent to test system also interacts with the contracts, those standard form contracts that the bug bounty might have in place, or the vulnerability disclosure program rules. So these are kind of contracts that define, what is the scope of the bug bounty, what is the scope of the authorization, and they come into play together with this key concept of authorization that we see that we know about in anti-hacking laws that have both civil and criminal implications. So CFAA, I imagine most of you heard about it. This is the federal anti-hacking law. Very interesting recent development on it, and I'm going to talk about it. But essentially, one of the key provisions, 1030A2, talks about this idea of intentionally accessing a computer without authorization or in a manner which exceeds authorized access, exceeds authorization, and obtaining information from a protected computer. And this is kind of the basis for potential criminal and civil liability. So the question of authorization is key. And the question of authorization under the CFAA has been, for many years, an issue of what we call a circuit split, where we have different interpretations of the law in different jurisdictions in the United States in different circuits. And what's interesting is it really, if you try to summarize the debate, it really is about how can you define authorization? Is it a contract? Is it a policy, an employee policy? Is it a bug bounty contract, or is it only, for example, circumvention of technical measures? So you gotta bypass some kind of technical protection. And we have seen very interesting cases, including recent cases coming from the Ninth Circuit in the matter of IQ. And the recent development that the Supreme Court actually took a case. So the Supreme Court is going to decide on a case whether basically accessing potential computer for basically an unjustified purpose, a purpose that was not the reason why you got the access to the computer. You got the access to the computer to do X, but you have accessed this for some kind of, unjustified purpose or some kind of purpose that was beyond the scope of the authorization. So this is not even just a policy or a technical circumvention. So this is a cert coming from the 11th Circuit and a Supreme Court case looking into the CFAA. So the next year, very interesting in terms of the CFAA, and the community should definitely follow. DMCA, another body of law, very relevant for embedded. We know that there are security exemptions for security research, specifically on embedded. The first actually exemption, that the temporary exemption, was for things like automobile, voting machines, medical devices. So there is an interaction there. Again, without going too much into the detail, prohibits circumvention of technological measures that effectively control the access to the software code. So the code is the copyright protected work. And really, it's a complicated body of law because they have exemptions to this prohibition, both in the law itself, but they also have an ability every 3 years for the Copyright Office to say, you know what, this is a very important type of activity for society, and we're going to exempt whoever is doing this activity from this DMCA provision for a period of 3 years, and they renew it from time to time. So we have an exemption for good faith security research. It has a bunch of conditions. You will need to go into the details and go seek your legal advice. But one of the recent kind of trends is they had a device limitation. It was for certain devices. And then on 2018, when they renewed it, they removed it. So we are seeing an expansion. And this was actually, there were kind of inputs and comments coming from the DOJ office that is really kind of leading the thinking about computer crime, and they've actually supported a lot of the expansion of the exemption, which shows a little bit of what they're doing in terms of building the relationship with the security research community. They also removed the term controlled from the nature of the testing, how it's carried out in which environment, with the understanding that some testing is not done in a laboratory environment. And with all these evolvement in the backgrounds, we have a very specific vulnerability disclosure kind of trends or resource that are interesting. So the DOJ, recognizing these are the real experts on the CFAA from the government, and they recognize this idea that researchers want to report, corporations want to put in place vulnerability disclosure programs, and there is an interaction with anti-hacking laws, and they put together a framework to consider some of the elements for organizations when they think about how to construct a vulnerability disclosure program. And it goes into issues like data minimization practices, how to minimize the interactions with users' data, or the issue of the safe harbor, how you can authorize access explicitly in the program to allow researchers to conduct the testing. So it's only a 7-page document, but it's really interesting. It's one of the key resources and kind of great, I would say, innovation and kind of resource coming out from the DOJ, recognizing some vagueness around the CFAA. Where all of this connects directly with the IoT security testing and research community is that we have seen a body of proposed regulation that tie this idea of having a vulnerability disclosure policy at place specifically to IoT. So this is just one example. The UK government, in putting in consultation, meaning they are thinking about a law, and they have asked everybody for comments. And they had their code of practice. This is kind of the next step. And now they responded to everybody's comments. And what they're thinking is they're going to create a law mandating specific requirements for IoT households. So this is consumer IoT security devices. It's going to have some interaction with the standard that I'm going to show you, a technical standard from ETSI with more detailed requirements. And they're going to focus on 3 issues: the issue of unique passwords and unique authentication, the issue of the vulnerability disclosure policy, so having that point of contact and the final issue around minimal lifetime time of support for security updates. So you see that the VDP issue, and this is proposed, it's not passed yet, but this is what they're kind of proposing and thinking. But you can see how the issue of the vulnerability disclosure program goes together with the IoT security conversation. And this is this ETSI they're referring to, but there is a new draft, I think, in progress already, but this is the draft that I found publicly. And you can see there is a specific section, there are capabilities, but there is also specific sections about reporting vulnerabilities. Now, isn't that interesting? Now, in the broader IoT landscape, we definitely have, a wide set of recent trends. So we have, federal legislation, we have state legislation. You probably heard about Oregon and California passed laws and laws that are coming on the way. In the federal realm, it's proposed legislation. So these are really bills like the IoT Cybersecurity Improvement Act. We have a real effort on consensus-driven kind of efforts that put together all the industry expertise to create a baseline for IoT security. So these are not laws; these are best practices and reports and standards. But they're consensus-driven. They're very useful because they kind of bring together all the industry as the landscape is evolving, and they're getting updated. So, for example, the C2 effort, that is the third one mentioned here, is one that is already in revision. It got published, it's already in revision. This is the nature of this evolving landscape, right? So we have kind of a bunch of efforts, both in standard bodies at ISO, at ETSI, but also at NIST. NIST took leadership, and they developed a NISTer 8259 in draft to release that looks into core security baseline capabilities, a really important document. I'm going to talk a little bit about that. Then we have proposed certification schemes all over the world, and we might see even focused legislation like I just showed you in UK. And finally, we have this overarching bigger trend on device transparency and this idea of ingredients, with NTIA leading kind of their thinking in terms of the software bill of materials. If you haven't heard about it, it really is an effort that came from kind of the IoT medical devices motivation. It looks into the value of having an ingredient list, if you will, of everything you have on the software for different purposes related to security, including, for example, vulnerability handling and the like, and patchability. These are the two consensus efforts that I told you about. I'm going to dive a little bit into the NISTer, but what you can see on the left is this document easily found online. It's more than 100 pages, very interesting, really diving into what are kind of the baseline capability for security for IoT devices across the board. So this is horizontal, all verticals, and there might be specific efforts for specific verticals, for example, industrial in the future. And what you can see on the left, you probably don't see the text, but the C2 effort had a really broad trade association engagement. So really the entire technology sector has contributed to this discussion. And if you look at what I showed you on the right, which is the NIST report on security capabilities, these are kind of the 6 capabilities they have discussed as kind of core, as fundamental for all devices. I'm just going to quickly go, it is interesting: device identification, device configuration, data protection, logical access to interfaces, software and firmware updates, as we have seen before, and cybersecurity state awareness. I don't have the time to go into the detail, but if you take one takeaway from this conversation today is open up the document. It is really useful. There is a table there. Read it through, and the table really goes into kind of the details in terms of what each capability means, and maps on the right the related provisions in other standards, in other efforts. So that's what you're seeing here on the right. I mentioned briefly the fact that we have proposed bills. This is one of them, the IoT Cybersecurity Improvement Act, with the goal of requiring some security requirements across all devices supplied to government. So this is using government procurement to raise the security of IoT devices. It has relationships to this NISTer that I just mentioned. Currently, Senate and House had different versions, and we will see where it goes. This is just one example of the many proposed federal bills that we have around the area of IoT, and we have specific laws. For example, this law in California that is in effect from January 2020 that requires certain authentication means and reasonable security features for connected devices. And there are definitions of a connected device. There are definitions of what, what type of authentication and when it might be needed. We're not going to go into that. There is a focus on, pre-programmed passwords, which are unique. Again, not going into the details, but just to give you kind of a taste of the fact that we do have specific laws on IoT security, and the landscape is definitely evolving. So it's an area where, we want to have that education and dialogue between the technologies and kind of the lawyers and the policymakers, because it's evolving. And as I see it, from my perspective, and I talked a lot, although it was a fast ride, about the relationship with the security community. There are opportunities. It's a big opportunity to facilitate those collaborations. It's a big opportunity to use technology to support trust, with individuals. The connected landscape is just going to grow. We have seen the importance of digital life for all of us, recently with this crisis, and technology can touch, each and every individual. And there is this momentum of fostering the trust from the foundations up. So, and the conversation is going to be not just about policies and collaborations and public-private partnerships and collaborations between researchers and companies and researchers and policymakers. It's also going to be about the innovation that we bring to the core. So how can we create technology that supports the security capabilities in this conversation? So among others, what's exciting me, although I'm speaking in kind of sharing my own opinion, but what excites me about working at Intel is the fact that, Intel is thinking about those kind of innovations that support basically integrity, that supports some of the recent trends that we have seen, like device transparency. So this is just one example, compute lifecycle assurance initiative that was recently released, and you can find all the information online that talks about the platform for integrity throughout the compute lifecycle, from the hardware going up with, an ability to extend trust throughout the product lifecycle, end-to-end product assurance, trusted supply chain and manufacturing, and assurance technologies. And we have definitely seen, kind of how the industry comes together and thinks about issues like, is the platform, arriving as expected? Is the platform and components are built as expected, and operating as expected, and operating, retiring, transferring, all of those issues. That's where kind of this notion of compute lifecycle assurance and assuring in platform integrity comes to life. And there is an opportunity, of course, in the technology itself, things like how are we going to create the capabilities for trusted execution and cryptography acceleration and platform integrity, root of trust, and the protection of data. So there are initiatives like secure device onboarding, which is late binding of devices in a zero-touch environment, not relying on users and passwords. And these are just examples. It's key that technology is going to play a key role in kind of bringing to life the security of connected devices. We're going to see more and more devices, and it's also key. And it's also kind of clear that as this conversation is going to continue and the attack surface is going to evolve and the technical landscape is going to evolve, we're going to have more and more conversations. We're going to have more and more conversations between policymakers, between researchers and technologists, and it's going to be all about collaboration. So I invite you to collaborate with us, with Intel, and submit your vulnerabilities. We do have a bug bounty program. It has a safe harbor provision as well. You can check it out. This ties into my prior work. I worked very hard when I was at Berkeley to create those kind of bridges by drafting template legal language that can go, of course, not as legal advice, that can go into contracts to facilitate safe harbors to kind of address some of the uncertainties that come with anti-hacking laws, and you can check these initiatives online. There are these serve as kind of templates. You need to seek your legal advice, but the idea is that with having those kind of open source like licenses or Creative Commons like licenses, one language, we're going to see more and more adoption of safe harbor language, explicitly authorizing access in the bug bounty. I spent a lot of time in the past working on it. I'm glad to report that it is now a very broad phenomenon. We have hundreds and hundreds of safe harbors out there, including one by Tesla. In fact, this is how I got my first challenge coin. I'm not sure if the first or not, but I never got a bounty from Tesla. I did got a challenge coin from Elon Musk, one of, I think, 20 in the world. And it's not because I hacked your Tesla. It's because we worked together on basically adding safe harbor to their bug bounty. But they did something interesting. Not only did they add a safe harbor, they also said that if you test your Tesla, if you happen to have a Tesla, by the way, Kevin Finster ordered a Tesla with the 30,000 bounty, and then I had to cancel the order. If you have a Tesla, you are an approved bug hunter under the policy. You need to read the policy. But if you're an approved bug hunter and you have a Tesla, you're testing your Tesla, something bad happened, because it happens, they will fix it for free. So they waive the warranty limitations for security research purposes, and cars, expensive cars, those type of embedded devices. This is a interesting novelty, definitely one to flag. As this ecosystem develops, and in embedded devices, the vulnerabilities are complex. There is a lot of complexity that goes into the process of remediations of vulnerabilities. It is this collaboration between the ecosystem, between the researchers and corporations and everybody in the ecosystem working together on the mitigations and finding vulnerabilities that is going to continue and be important, especially in embedded and IoT, because we know these are complex systems. So this is just one reference to an interesting paper that talks about the complexity of code and vulnerability disclosure, specifically in the context of hardware systems. And with that, this has been a very fast ride. I'm 3 minutes before. I hope I'm still on time. I want to close it up and really, thank everybody for tuning in today. I'm going to try to join Discord to be available for your questions. And we can definitely continue the conversation over, Twitter or wherever you like. I hope you enjoyed it. My main takeaway and something that I truly believe in, and that is why I'm engaging in my job, is, this collaboration, this dialogue, talking with you, hearing your questions, and following up on kind of those interfaces that we are seeing between policy, technology, and law. That is going to be very important for the future, especially in a landscape like IoT security. Thank you so much, and thank you for having me.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, a medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, a lot of hackers work in these small groups. They don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.
Cool. Thank you guys. Thanks for the opportunity to speak. I'm Arun. I'm a security researcher with Forescout. And yeah, so every time you see a flat network, you ask this question, right? Do you even segment your IoT network, bro? So this will be a brief overview of my talk. I'll talk about IoT in the enterprise. I'll give you some background on network segmentation and describe the problem. And we'll do a case study of healthcare networks, and we'll conclude this talk. So believe it or not, 1 in 5 devices you see in the modern enterprise is now an IoT device. And this is just the average. There are many industries where it's 1 in 3 devices. So what are they? So you see things like these IP cameras, you see VoIP phones in the meeting rooms, you see physical access control systems like the pad swiping mechanism, which lets you into the office. And if you're a hospital network, you'll encounter things like patient monitors and X-ray machines, and the list goes on and on, right? So this is a large pool of devices to attack. And interestingly, these devices live alongside IT devices in production. And we know these devices are making headlines in all the wrong ways. Right. So you remember the incident from a couple of years ago where a Vegas casino was hacked through its smart fish tank thermometer. So attackers moved laterally through the network to a database, stole data from a high roller database that the casino was maintaining and exfiltrated it through the fish tank thermometer. So that was a crazy incident. And you see other instances where the IoT device itself is the end target, something like a hospital network in the US getting infected with some ransomware, right? So what makes enterprises vulnerable to such attacks? So our hypothesis is that in a majority of cases, it's due to bad IoT network segmentation hygiene. So from the perspective of the attacker, network looks something like this tasty nugget right here with a crunchy exterior of security controls. And once you get inside the network, it's pretty much a treat. So it's kind of a GUI center type of a network design. And in most organizations, the IoT device management process is not as mature as the traditional IT, like a Windows machine that the corporation owns, right? And the other characteristic is that new devices are getting connected to these networks, often without the knowledge of the admins themselves or authorization. So this is another issue. So let's step back and look at the basics of network segmentation. So what is it really? So network segmentation is like a process of splitting a computer network into subnetworks. So something like the slices you see in this pie. Each slice has its distinct constitution, which is separate from the next slice. And in terms of networking, you achieve this with a combination of methods at different layers of the networking stack, right? So at layer 2, you have VLANs, which are a common way to limit the broadcast domain. And then you have layer 3 firewalls, ACL, subnetting, and layer 4 and higher layers, right? So usually segmentation is achieved by a combination of such methods. And it's important to get the foundation of segmentation right. So you can't just have higher layer controls without having lower layer segmentation working. So just like this house with a weak segmentation, weak foundation, if you build a network with higher layer controls, then it's a weak system. And this translates to, due to many different attacks which can happen in such a scenario. I won't go into detail for all of them, but essentially an attacker, if he's in the same, let's say, broadcast domain as the device he's trying to attack, then essentially he bypasses router ACLs, firewalls, and gets to the end device pretty quickly. So he can also observe things like broadcast traffic, multicast traffic, link local traffic, anything, if he's on the same broadcast domain. And finally, even if the attacker wants to carry out, let's say, ARP poisoning or any other low-level attack, then it's pretty much a done deal. So with this in mind, let's take into account a case study of a healthcare network segmentation. It was interesting that it was mentioned in the introduction that healthcare networks were something that ISE have encountered to have problems with. And healthcare environments are kind of unique in that they have a lot of sensitive devices and data, which are usually high-value targets for attackers, right? And hospitals have adopted IoT in a big way. So everything from the bed that this patient sleeps on to the X-ray machine, which is used in the medical cards, everything is on the network. And finally, other characteristic is that many of these medical equipment still run old versions of Windows and other vulnerable software firmware. So with our data set of ForeScout Device Cloud, we have collected over 4 million endpoints worth of network metadata from over 250 large deployments of ForeScout, using which we can do some segmentation analysis. So for each of this device, we can identify the type of the device which is connecting to this network. The device may be an X-ray machine, a printer, a smartphone, or whatever. We are able to fingerprint what each of these devices are, and we can also identify the layer 2 network segment that the device is connecting to, right? We'll use this in our future slides. So first, we asked the question, are healthcare networks actually trying to segment the network better than the non-healthcare counterparts? So the non-healthcare may be something like an educational institution, a retail environment, and so on. So it's kind of good to see from this graph that, in fact, 40% of the healthcare environments we have in our data set have over 100 VLANs. So that's a good thing compared to only 10% of the non-healthcare verticals who have over 100 VLANs. So this means that overall, yes, there are more segments in the healthcare environments, but is that good enough? We'll see later. So the other characteristic we found is that in healthcare environments, administrators often tend to create vendor-specific segments. So if there are particular vendors that the hospital buys from, so for instance, Philips or GE Healthcare, there will be separate segments dedicated for those vendors. So that's another good thing that we would say. But again, it's limited, dependent on the number of devices in these segments and the types of devices. It may need further granular segmentation. So let's take a look at what an actual VLAN in a real hospital network looks like. So what you see here in the figure is an instance of such a VLAN. So there are different sorts of equipment. They may be healthcare devices like blood glucose monitors, infusion pumps, and so on. And in the same segment, there are other non-healthcare IoT, something like surveillance cameras and things like that, in addition to traditional IT like computers, printers, mobile devices. You may think this VLAN looks a little bit weird because it has a bunch of different types of devices. But in fact, for a majority of instances, we see that this device mix is common. In fact, it's over 90% of VLANs have a mix of healthcare and IT devices. And about 60% have a mix of healthcare and other IoT. So this is the norm, not the exception. And what's the problem with having such a device mix, right? So we know that many of these IoT are inherently vulnerable. They may have default credentials or other vulnerabilities. So in this example, we see an instance where a patient monitor has a default login. And in the same segment, there are other critical healthcare equipment like infusion pumps and blood glucose monitors and medical cards and so on in the same segment as this vulnerable machine, right? So the presence of this vulnerable machine introduces risk to this entire VLAN, and it changes the security state of the VLAN, and that's an important thing to know. And as it was alluded to earlier, so there are instances, real instances from hospitals we have observed where there is one VLAN per hospital floor or one VLAN per location, and this is really dangerous. So this means that any device on a particular VLAN, so let's say you're on a hospital floor and you're connecting your X-ray machine and let's say your computer or smartphone to the same network, you can reach the X-ray machine through your smartphone. That's not really a good thing to happen. And what we observed is that these situations occur where the networks have been inherited from some previous IT security teams. And yeah, basically it's a lateral movement bonanza. And there is also other issues. For instance, if you buy a new Cisco switch, we have what's called as a default VLAN on the Cisco switch, where all the switch ports on most of these switches are default connected to VLAN 1. So all the devices on VLAN 1 will be able to talk to each other. And it's recommended to never leave devices on VLAN 1 for security reasons, specifically so that if an attacker does end up on VLAN 1, he has nowhere to go. He can't move laterally. So that's the idea. And additionally, you shouldn't set VLAN 1 as the native VLAN because the attacker can do VLAN hopping or delete the whole VLAN database, and other bad things can happen. So the question is, how are healthcare environments doing in this VLAN 1, right? So on the figure on the left, each blue dot represents a healthcare environment, which we have in the data set. In the y-axis, you have the percentage of devices found on the default VLAN, and the x-axis, you see the unique device count of each of these environments, right? So what you see here is that many organizations are trying to minimize the default VLAN usage, but really surprisingly, there are a bunch of dots here for which the number of devices on these default VLANs are at least a quarter of the entire device population in those environments, right? If you see the order of magnitude, it's in the order of thousands of devices on the default VLAN, and that's really concerning. This is a fail. So what is on the default VLAN? So in healthcare environments, you see critical equipment like patient monitors, X-ray machines, pneumatic tube systems, so on. And it doesn't stop there. It also is a problem in non-healthcare environments. You see point-of-sale devices, IP cameras, and so on. And again, what are these guys thinking, right? So why are people making all these bad segmentation decisions? So what we see is that organizations often don't have a comprehensive segmentation strategy. And in fact, a Gartner report says that less than 1% of enterprises have implemented a virtual segmentation strategy in 2019. So the other reason is people don't know what's connecting to their network. So there are so many devices in the order of hundreds of thousands that administrators find it hard to actually know at all instants of time what's on the network and what's not. And there's a lack of understanding of the device context. So for instance, if an IP camera is on the network, is this IP camera involved in surveillance, or is it something used in a video conference room, right, or a meeting room? So this device context is important to set the conditions for which what traffic is allowed from the device to where, right? So this context determines segmentation, and administrators don't have access to such understanding. And in some cases, it may be that there is a trade-off between security and convenience. So maybe, having a flat network is easy to maintain, but is it the right config? And as I said earlier, there are some instances where there are legacy networks inherited from maybe an acquisition or another team. And in a healthcare environment, let's say there are real patients using patient monitors and X-ray machines, and you suddenly want to change the segmentation, and you don't want to break the patient care because of what you're doing. So that will introduce some hesitation for administrators to fix the problem. And there are equipment which can't be patched. So hospitals don't keep buying the latest X-ray machine, like the latest iPhone. So these are bought like once in a decade, and they're run sometimes really old versions of software which may not even be supported anymore. And finally, they may ask the question that we have such a high diversity of IoT in our environment that how will I deal with the segment explosion if I do create these segments, right? So these things are happening as we speak. So is there light at the end of the tunnel? And what are some guidelines? So we recommend that segmentation should be intentional. So whenever a segment is being designed, you should take into consideration the IoT device context and purpose. So you can infer this context based on the traffic patterns and also the device type. And the other thing is we shouldn't wait for these issues to occur from vulnerable IoT. So you should be proactively looking for vulnerable IoT and think of segmentation as a dynamic process, which will change according to the security status of the IoT device. And we should also avoid having these higher layer controls without getting the foundational basics right. And this is another problem we have observed. And finally, we should try to use software-defined approaches for segmentation, which will be able to deal with the scale of thousands of devices and device types. And finally, if you're a healthcare organization, there are some recommendations by NIST you can follow. NIST recommends a zone-based security approach. And in the figure here, you see that there are different VLANs being created for different purposes. So there may be a separate VLAN for biomedical engineering versus a another VLAN for clinical services. And each of these VLANs are access controlled, and which segment can talk to the rest of the segments. So there is strict control between these segments. And there are some glimmers of hope. We see some instances of VLANs in production who are trying to better segment the medical devices from the guest VLAN. So for instance, in the guest VLAN, you may see things that people connect to in the lobby of the hospital, something like smartphones, tablets, e-readers, which is completely different from the medical segments, which may have glucose monitors, infusion pumps, and so on, right? This is good. So the question is, what did we learn from all this? So is it enough to perfectly patch an IoT device? So the answer is no. We need to ask what the security state is of the device neighbors. So this is not talked about enough. Everybody focuses on the vulnerabilities in the IoT device, but nobody thinks of what network environment it's actually in, right? And we should also limit what the device can talk to, who the device can talk to, and understand why it's talking to that endpoint at the other end. And we should ask, is the device in the right segment based on its role? If it's a medical device, it should be on the medical segment, and so on, right? The other thing to understand is that IoT security issues can be amplified by poor segmentation decisions. So even the presence of one weakly secured device can affect the risk status of the entire segment it lives on, and even more. And so it's important to act proactively and get an understanding of the situation in your network and be dynamic about segmentation. And as an enterprise, you will need a comprehensive strategy for segmenting your network. So we see from our results that many enterprises are trying, but we still definitely have a long way to go. And VLANs won't solve everything. So we need higher layer controls as well, and we need to keep the traffic from the device, which is going to the intended destination, not somewhere else. And we have talked about the zone-based security approach recommendations. And if you're doing a zero trust kind of strategy, do include the non-user devices, something like IoT in your network as well in that plan. And finally, you should move away from the illusions of security. Just because you have a bunch of security vendors in your environment already, that may give you a false sense of security that you should move away from. And you should get the basics right in order to ensure you're moving in the right direction. And AI is not always the answer. So network segmentation, let's do it, guys. That's my talk. Thank you. And you can reach me on Twitter, and also I'll be happy to answer questions in the Discord server. Thank you.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, the medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, a lot of hackers work in these small groups. They don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.
So the topic today is the effects on, or the effects of IoT devices on corporate networks. As you can imagine, we're in this weird time where people are working from home due to COVID. If you haven't been working from home, on a day-to-day basis, and let's face it, everyone has IoT devices in their home, whether it's home assistants or smart fridges. Me being included in that group of people, the question comes down to, how IoT devices, if they do, right, pose a threat to corporate networks. So with that, let's kind of kick this off with our first question. It's kind of a softball, but it kind of gets the conversation started. So my first question, and please chime in, it's what challenges do your organizations face during this unique time? Jay, you want to kick us off, and then anyone can chime in after that?
Well, it's kind of tricky to talk about the organization that I'm part of and the challenges that we're facing, right? Because, being in InfoSec, I have this not necessarily desire to be outspoken about our own internal issues that we haven't fixed and published yet, right? But that being said, it doesn't mean that we are not familiar with the common vulnerabilities and the common issues that are faced by companies in general. And to that end, I do have a story. I was in this meeting, I think it was about 2.5 years ago, right after we published a paper on a smart power outlet. And we managed to get a root shell on the smart power outlet relayed by the cloud of that smart power outlet. So essentially, we didn't need any kind of direct connection with it. We didn't need any kind of bypassing NAT. We didn't need any kind of the power outlet to be directly exposed to the internet. We would get our connect back shell from the power outlet by relaying a command injection through the device's cloud. And I was in this board meeting room in this huge company in the US. And then the CTO of that company says, so I saw that you published that paper. Is that real? And I go like, yeah, it's real. And he says, okay, hack my house. And that's like a really awkward question to ask and a really awkward thing to answer, especially in a very formal environment. I wasn't wearing a shirt. I was wearing a t-shirt. I actually had a tie. I know it sounds a little bit weird. I had a tie on, and I was looking very presentable and official and formal and all that stuff, right? And then the guy said, okay, hack my house, because I have one of those devices in my house. And the thing that you needed in order to be able to get a root shell of the device was the MAC address. So I tell the guy, okay, if you give me the MAC address of the device, I get a root shell in your house. And he says, no. And I said, yes, and blah, blah, blah. And then he does a remote connection to his house. He gives me the MAC address of the device. And, well, long story short, I get a root shell in his home network. And then I start telling him, okay, and then I tunnel into your home network, and then this is all of the devices in your house, and this is your Wi-Fi password, and all of that. Because I had a root shell on a Linux-based device in his own house. Arguably, the whole thing had like 3.4 megabytes of disk space. You couldn't do that much, but you could do a tunnel, so you could like pivot through the device in order to be able to kind of launch all kinds of stuff towards the other device in the house. And that kind of taught the guy, and even me, a very important lesson. You really don't know what's happening with the devices that you have in your house. You can buy a power outlet, you can buy a vacuum cleaner, you can buy all kinds of gadgets, right? Or a smart baby monitor, or all that stuff. And I could have a root shell in your house, and you would have no idea that I have a root shell in your house through that device. And then through that, and this is the catch. 3 months ago, if I told you that your home network is supposed to be as secure as your corporate network, you would have laughed at me. So if I said that, your home network is supposed to be just as safe as your corporate network, or as I like to put it, your corporate network should disappear entirely, and you should move towards zero trust. Then people kind of laughed at me. No. Corporate network is definitely more secure because we invested hundreds of thousands of dollars, if not millions of dollars, in these all those barracudas and all that stuff that we have like bordering our corporate network. Well, right now, your home network has to be just as secure as your corporate network used to be. And this is the kind of thing that I think that should sink into people's minds. And maybe I'm wrong, and this is one of the things that we should debate here, but that's kind of how I see things right now.
Cool. How about you, Eric?
Yeah, I would say maybe your home network doesn't need to be as secure as your corporate network, but your endpoint that you're allowing into your corporate network needs to be validated. So you should be able to deploy these endpoints into potentially hostile networks and still have some check before they come onto your corporate network in order to validate that they haven't been compromised by that hostile environment. So that's, I guess, kind of your zero trust thing that you were going for. But yeah, I think that going forward, that's going to be the solution to these kind of issues.
I definitely like that. Definitely like that answer, because it kind of ties in or kind of feeds into one of our other questions that we have for you guys. But I'm not going to dive too deep into that. I'm going to give Gary a chance to respond to this initial question. So Gary, do you have any insights?
No, I'm just saying, I approach it as from a CISO perspective, and I'm talking to a lot of my peers right now. A couple of months ago, you got 800 employees and they're all coming into buildings. They're all coming in the networks that you've built. They're coming in and they're on things where you're running your stack, you're looking at their assets, you got projects in play, and then all of a sudden you're telling 800 people to go home. And they're picking up their laptops, they're picking up their phones, their cell phones, and they're going home and they're connecting from home, to go ahead and continue work. And it opens up. And even if you're fully 100% cloud and you're using Office 365 and Slack and and Zoom to go ahead and pretty much run everything, to where you pretty much push most of the risk onto their stacks and into their data centers, you've still got issues. You've still got things where you're wondering about the networks, and now all of a sudden your assets are running in on a daily basis. You're also thinking about, these people have, corporate cell phones, which have been issued to them, and now they're asking for apps to be downloaded that you really haven't vetted, because now they want to do DoorDash, or now they want to do, because they're basically running their office from home now, and they want to be able to have that same usability, and I used to always joke that one of the biggest problems I would have with employees when they had like a corporate laptop is that the longer they have that laptop, the more they start associating it with their personal laptop. And you start having that creep of going to sites that they shouldn't go to, or asking for software that they don't need and stuff, because they get so attached to it. Now, what do you do if that laptop that they're attached to, you send them home and they're freaking working from home? What I'm saying? It's just all of a sudden you find from a security stack perspective, if you weren't doing zero trust, you're doing it now, just because of the fact that you have to. Myself, I'm fully 100% cloud. I don't have anything on-prem. Everything's cloud. And so we're living and dying by zero trust. That's how we manage things. We're already looking at, to me, the security, my stack, everything's focused at the data layer. I'm focused down at that layer, and I'm looking at what people are accessing and what they have permissions to, what their roles are, what groups they're in. I'm looking from the insider threat piece as to what they're doing with data and how they're changing it and where that data is going. It totally flips the way you look from a security perspective, because all of a sudden there's nobody in the buildings anymore. They're at home, and you can't look at the homes, but you got to kind of associate that there's some level of at least some type of security or some level there. And as Eric was saying, you kind of move security down to the endpoint, and you start looking at, okay, because that's the core piece that you've got left of the company, that you can see, and what the person's doing. And so, besides just the whole AV and EDR piece, you start looking at then, what's going on that asset and what it's touching and what they're doing with it, and definitely you want some pieces in your stack tied into your SIEM that's doing a behavioral analysis piece, so you can actually start tracking over time what these people are doing. So you're trying to put other things in to give you visibility, because you've lacked that visibility now because they're no longer on your on-premise anymore. They're now at home. So it opens up some really interesting. To me, I think it's cool because there's been a lot of architectural changes that I've always wanted to try, and now that I'm in a fully cloud environment, I get a chance to do it. And so I have to admit, it's really cool. I just was talking with a startup earlier today that we're working with, but yeah, I find I'm talking with a bunch of different systems right now, and we're all running into this, and even a bunch of us are talking 6 months from now, we don't expect everybody to come back. We're expecting it's probably going to stay hybrid. We're probably going to have a chunk of our workforce that's going to be working from home. That's going to be the new norm. So how are you going to incorporate that now into your policies? How are you going to incorporate that now for incident response? If you're responding to an asset that's been breached, but that asset is in somebody's home in Illinois, what do you do? Besides isolating it, there was these kind of discussions where like, we need to start factoring these into tabletops. I need to start, building muscle memory into my teams for tech support on how we're going to deal with incidents like this. But that's everything I'm running through right now on a daily basis.
Yeah, cool. So it seems like each one of your organizations has already been through the threat modeling process, right? You guys mentioned zero trust here and there, and kind of shed, a little bit of light as to, the security controls that you have implemented to keep your network secure. So I want to kind of like go into, a little bit of detail into, what that process looked like for your organizations and what types of controls that you guys implemented to, keep your sensitive assets, protected, right? Would anybody like to chime in first, or should I pick and choose?
If I may, I don't have a question before that. Is that okay?
Yeah, sure.
Okay, so this is an open talk, right? So we're gonna do like a panel, right? So I know I'm not a moderator, and I apologize if I'm a little bit, like above, overstepping my boundaries, right? But I would be curious if anybody says the pandemic is a positive, in a sense that it's kind of pushing and forcing companies towards zero trust, towards proper IAM, towards proper identity management systems, right? And towards proper mechanisms to kind of eliminate the corporate network and all that stuff. And I would be curious if people see it like this as somewhat of, I know it's definitely not a positive in so many regards, but is it a positive in the sense that of pushing organizations towards the right thing?
And actually at lunch I was in a Zoom meeting with about 40 CISOs. We all were kind of coming together and talking, and just kind of, hey, your day sucks, this week sucks, this is what I'm dealing with. The whole freaking world sucks. But we're like, we're chatting with each other, and across the board, what I'm hearing is that a bunch of us, we may in January, we thought strategically what we were doing for the next 12 months was planned out. Obviously, in March, all that shit went out the window. And a lot of projects shifted. And honestly, I mean, what we're going through, I think totally sucks. And I hate the impact it's having on society and the fact that, people are dying. But I also look at, internally within businesses, some businesses are playing catch up. Some businesses are getting where they probably should have been at 2 years ago. And the fact that, this black swan event that we're in is a protracted event, and companies are having to shift. Companies are having to adjust to this type of an event. And a lot of it, no matter how you look at it, I mean, I've always looked at, for me, technology, for me, cybersecurity is managing risk and the impact on the business. And a lot of that risk is decisions that the business makes with regards to technology, whether they have decided to implement new technology or whether they've decided not to implement technology and use that funding for other operations. What started in March, especially for the United States, a lot of those decisions got totally flipped. And now companies are having to shift because they want to stay in business, but now they have to work with remote workforces. And so there's new technologies that they got to put in play. So, I mean, the only kind of I guess you could say bright cloud out of this, in some ways might be the fact that, some companies are actually becoming more secure. They're getting better. Where I honestly look at, they probably should have been a year or two ago. So unfortunately, the event that we're in, I think, is forcing companies to adapt and is forcing companies to make changes. And what I hope is when we get on the other end of it, this isn't just a one-off. What I hope when we get on the other end of it is that this is the new norm. That this gets ingrained in business. And a lot of the security practices we're putting in now just isn't to get us through this emergency, but becomes, no, this is our new architecture. This is the new way that we're going to go ahead and do things. We should have been doing it this way anyhow. And so I'm really hoping to see that happening. I mean, what I'm hearing right now from a lot of my peers, it's 50-50. Some businesses are treading water. They're doing what they need to do and hoping to just get on the other side of it and be able to still be functional. Some of them are looking at it, hey, we're going to make these changes and we may lay off 10 or 20% and get lean. And then when we get on the other side of it, we're going to bust out and just go ahead and grow again. And the changes that we make technology-wise, we're just going to incorporate that into our overall strategy and keep moving forward. I think, like I said, a lot of it's in flux. But I do think that this event that we're in, like I said, this protracted black swan event that we find ourselves in, it is pushing a lot of technology change, and a lot of it's tied in with security. Because companies need to adjust, they need to put in these new technologies, and a lot of the systems are like, okay, we're moving this quickly. Here's the risks. Here's the impact. What do we want to accept? What can we deal with right now so that we can still be effective and be able to remediate? I mean, and so a lot of it's fast moving.
Yeah, I agree. I think it is going to be a net positive for security long term. And I think you're going to see in the higher levels of management, people are always going to ask, can we support another event like this if everyone needs to go home for a month? So I think that if people don't have it in place now, it's going to be a question that comes up. And as someone who's done pen tests and seen the GUI center of some networks, I think it's better when there is no boundary and every endpoint is monitored like it was a valid high value asset.
Yeah, I mean, I can tell you we're doing audits, because we're regulated. One of the things I found interesting that was actually asked by one of the entities that was regulating is they asked us, hey, this is the first time I'd ever seen somebody ask this too. It is in your business continuity plan. Do you have anything that deals with pandemics?
Really?
I can guarantee, and then so people are starting to ask now. I can guarantee you, only some big companies like say Intel that think far-reaching and try to do stuff like that probably had something. Most of us probably didn't. Most of us had some type of business impacting, like a volcano or a hurricane knocking out part of our supply chain or something like that. I don't think anybody was thinking about a pandemic or the zombie apocalypse or something like that. But I can guarantee you, moving forward, people are going to be thinking about some type of pandemic because they're seeing it live now, the impact on business and what it does, and just the rippling effect it does through supply chains. Companies are going to have to plan for something similar to that now. And I can guarantee you, regulators are probably going to ask for it now.
Well, but I think that's your point, Gary, is amazing because it kind of shows the position that so many companies are in right now. But and this may be just me here. Personally, I don't think that companies don't know or are unprepared for this, because I strongly believe that at least on the security side, the CISOs, the security officers, or the vulnerability managers or the red teams do not necessarily care about the pandemic. For them, it's business as usual. They need to develop their threat models, and they need to understand how to compromise assets and all that stuff, right? But I would argue, I would want to understand if the pandemic is really having a negative effect on assets, or is it more of a process versus reality thing, right? Because process-wise, yes, it's not a comfortable place to be in, right? Process-wise, we were not prepared for this. But me, I'm a red team, right? So as a mantra, as a thing that I'm doing on a day-to-day thing, right? I'm red team. And for me, the pandemic is just another phishing vector, if you will. And I would argue that companies that go towards process are more affected than companies that go towards reality, if you will, right? Because And this is a question that I would be curious to see your answering, especially you, Gary, because being a CISO, you have to deal a lot with the due diligence and compliance and process, right? How do you see the gap between process and reality? And especially in this time, because right now, reality has a harder effect than process, right? Because we're being hit with something that was unpredictable.
Yeah.
When you're hit with something unpredictable, then process is good, but being able to cope with reality might come in more handy. I don't know if I'm being coherent enough.
No, I mean, I actually understand what you're saying, because, and honestly, this is why I'm on several Slack channels with a bunch of CISOs, and we're talking back and forth on this, and we're sharing information and helping each other. You know, and I've written articles about this, that, you know, you put policy in place, you put procedures in place, you train your teams, but when you have an event like this that is so, as an outlier, that's outside the norm, that's also why you have the whole Gumby factor. You got to be able to pivot. You got to be flexible. You got to be able to make changes, because you're going to shift your stack. You're going to shift technology, because the whole business is going to change to deal with the new norm. You know, and so from a security perspective, from a CISO perspective, it's interesting. I mean, technology changes, and a lot of the mindset, our job is still going forward. We're managing risk, we're protecting the business, we're helping them with new operations, we're still onboarding employees. One of the changes that we do see is actually on the people side, because now I'm really concerned. I've got staff at home working from home. They're putting in 10, 12, 14-hour days. You know, there's no break. You know, and I'm really concerned about burnout. I'm really concerned about, you know, the fact that they need to take breaks. You know, that, you know, we're watching each other now to watch out for that. You know, we're even building in, you know, extra days of leave each month, so people can just, if you just need to take a break, take it. You know, because you've got kids running around now. You're in the middle of a Zoom meeting and a dog comes running in and a 4-year-old's chasing the dog. You know, and that's become the new norm. You know, and I don't care. We just go on about our business. But the thing about it is that, you know, a lot of it, and it was funny, a lot of us were talking about this, was that, you know, when you go to work, it was a way where you were able to split the two, and you got some relief from one environment or another. You don't have that anymore, you know, and so you're used to taking care of the technical stuff, but now it's the people thing that I watch out for. And even for yourself, you know, what I find a lot of times in security, we're already used to stress. We're already used to the fact that, you know, there is no light at the end of the tunnel. There's just one freaking long black tunnel, because cyber's this, you know, this whole life cycle process. It's continuous. There is no end to it. You know, just as you finish one thing, you've got other things to do. You know, just as you finish one initiative or one breach or one cleanup, you're working on the next thing. You know, and so there's always been some level of, you know, stress that you got to deal with. So what I'm seeing now, the new norm is there's a lot more of that. You know, and for us, we're watching that with the staff. We're watching that with the team, and making sure that people kind of take breaks while we're still following our processes. I can tell you, I've probably rewritten or gone through at least 21 policies now, and haven't had to make changes, you know, because of new things that we're doing. You know, we've some of our projects that we were doing, like with SIM and some other stuff, you know, we realized we needed to make a couple of changes, because now I've got people that are working remote. There's data sets that I want to look at now that I didn't used to have when people were in the building, you know, and so it's stuff like that, you know, that, and you have to be flexible enough to adjust. What I find, you know, those CISOs that I'm talking to who are panicking or just having a hell of a time, is when they're 80% of their infrastructure is on-prem, and they use a bunch of SaaS, and now all of a sudden they're trying to move a bunch of this stuff. But how do you move it when you're in lockdown and people aren't supposed to be out of their houses or whatever? You know, how do you know what I'm saying? And they're having a lot of problems with that, and trying to give, and so there's been a lot of discussions as to, okay, who's available? What companies are still working that can help move things into a third-party data center? You know, and timeline-wise, what are you looking at? You know, it isn't immediate now. You know, there's going to be a lag and stuff. You know, but yeah, it's like you said. There's a lot of shifts and things. It's definitely not normal as it was 3 months ago. Sorry, I don't mean to ramble.
But it is the new normal. So, I mean, I guess the question that we would want to know, and do we want this to be the new normal?
I have to admit, I mean, it's what I would actually like to see, the op tempo and everything we're seeing. I think a lot of companies are not built for this type of op tempo, and you're going to burn people out. What I would like to see is some type of a hybrid. I'd love to be able to see when we get on the other end of this, companies that basically forced everybody to come on-prem to buildings are a lot more lenient towards working from home and are willing to go ahead and have a hybrid deployment to where, if I've got 30-40% of my staff that want to work from home, that's fine. And if I want to do 30 or 40% that rotate, like 2 days in and 3 days out, that's fine. If they're willing to do that, the CFOs would actually save money because you wouldn't need as large a building footprint. I look at it from a recruiting standpoint. If you've got a larger group that's working from home, you got a lot more people now that you can go ahead and recruit from because they don't have to be in the same geo area. There's a lot of pluses. I'm just hoping businesses learn from it and actually, take advantage of it. I'd love to be able to see that on the end of this. It's frustrating in cyber, especially when you get up to the executive ranks as CISOs. I know very few CISOs that are allowed to go ahead and work totally from home. Almost all of us, they force us to be on-prem. It's almost mandatory. They want you on-prem. Even though our stack and everything else is in the freaking cloud and everything else is deployed everywhere. But I understand because a lot of the CISO role is now becoming a business executive role. You're becoming tied in with the C-suite. You're getting more of the enterprise, more of the executive view, and a lot of that is personal. A lot of that is relationship-wise. It's relationship-driven. So I'm hoping they start allowing us to do some type of a hybrid, allowing us to commute, allowing us to, what I'm saying? It's going to be interesting. But just like you said, I really hope this is not the new norm.
Okay, so two things here, very quick. First of all, I'm not entirely sure that there's going to be an end to this because you said at the end of this. And second, Drew, I sincerely apologize. I hijacked your panel. I'm sorry.
No, this is good. This is great. This is great dialogue. I want it to be natural. So continue. Yeah, this is good stuff. I think the audience is really enjoying it.
I'm working to the side. My Slack channel, several of the Slack channels, there's a bunch of the CISOs that are in this, and they're all throwing comments at me. So it's just like, so far they're positive. They ain't giving me any shit right now. So far.
Cool. Yeah. So, I guess back to my original question before Jay hijacked the panel.
I'm sorry, man.
No, that's all good. Don't worry about it. My question was surrounding, threat modeling and kind of like how your organizations leverage the threat modeling process to further your network security. Anyone shed any light there to kind of give the audience some tips and tricks?
I mean, I can tell you for this, we basically brought in a third party to kind of lead the discussion, because I mean, risk, compliance, legal, IT, InfoSec, you get everybody in a room and it can be a long drawn out argument. Everyone's got their own opinions. So you bring in a third party who kind of leads the discussion, and that's basically what we did. We brought in a third party. We started laying out, and it really began with first just kind of identifying what the critical systems were, the critical data, kind of understanding how the business operates, and then with that type of data, and you have a better idea of what you need critical, wise to be able to function as a business when you have an event like what we're in right now. That kind of starts leading us into, being able to do tabletops and start doing scenarios around what we need to protect and how we would actually, function, in an emergency or something like that. But, that's what we did for threat modeling is we actually brought somebody in to kind of kick that off. So we got used to working with each other, and then we started breaking down. And of course, we have offices in like 30 different countries. And so some threats in the United States might be different than like in the UK or like over in EMEA. And, so we, so it was one of those things too, is we had to bring people in from the other areas also, so we could try to make sure we had a wide ranging, model that would work depending on where an incident was at. And like I said, for us, it was, bringing the third party in really helped us. It just kind of helped us focus on where to get started.
Good stuff.
Yeah, here at 610, we are mostly remote. So we were kind of ahead of the curve for this stuff, but helping customers, I think you do the same threat modeling process, but now you have to look at endpoints that aren't under your direct control. So how are you validating that those endpoints are still secure and can access your data? And then how are you monitoring that access and detecting anomalies in that access? So Gary mentioned the SIEMs and the anomaly detection and behavioral analysis, and that's something that we definitely push.
Well, personally, I cannot confirm or deny the fact that we got an external consultant to kind of help us with stuff. But I think it would be a good idea to kind of share a few tips. I think it's always a good idea to get an external third-party view. Or at least it's never a bad idea, right? Getting an external pen test or getting an external consultant to kind of have a look at your infrastructure, always a good idea, definitely. It doesn't matter how big or small you are, it's always a good idea. And then having an inventory of your assets. I know this sounds like a cliche and everybody's trying to do it, but I would bet, Gary's salary of 1 month, which is like at least $500,000, of course, that not a lot of people are doing it, right? So getting a bit of focus on that inventory of assets is definitely a good thing, with or without consultancy. And if we're talking about IoT, I can tell you for a fact that literally all of the organizations that we've talked to, because us, we are a security company and we do defensive security, right? And we provide cybersecurity solutions to kind of defend against cyber threats and all that stuff. And that's great. We also do offensive, and that's where I'm involved, right? I'm involved in doing research on methods that can be used to hijack stuff and to hack stuff. And the companies that I've talked to, all of them, and it's not a small number, at least 1 or 2 brands of IoT devices that will be hijacked, for example, through cloud command injection attacks. And they had no way of knowing that was happening unless they hired outside help to kind of dig deep and investigate the devices that they had in their corporate network. Arguably, segmentations and VLANs and all that stuff helps, but it's not as good as you might think. So my advice would be, besides obviously get consultancy, yes, that's a good idea. Get pen test, that's a good idea. Do bug bounty program, that's an awesome idea. Your red team, and if you don't have one, get one. Do an inventory, and then start doing a little bit of vulnerability research into the brands that you have installed in your infrastructure. And in all fairness, vulnerability assessment and research in IoT, it's not really as difficult as it may seem. You can look at what we're doing. You can look at what ISC is doing. There's so many helpful, quick start guides into how to do hacking in IoT, and it's really very, very easy. You just have to invest like 1 day, and you can hijack clouds and IoTs from lots of infrastructures. So yeah, get consultancy, definitely get pen tests, yes, start bug bounty programs if you don't have them already, yes. And also start researching vulnerabilities into the brands of the devices that you have running into your corporate network. That would be my advice.
Cool. Good stuff. Not sure if a shameless plug is appropriate, but ISC, we are a consultancy. So if you have any questions, feel free to reach out to us. We'll definitely get your security in a great, point, and you'll be in great hands. I want to switch gears to the audience. I want to at least get one question from them. And we have one question. I think you guys are a good audience to ask this to. Have one question about how, what is the best approach to educate your team members about the risk that organizations face with people working from home, with IoT devices connected to your team members' home networks. So does anybody have any, I guess, any insights on, various strategies or approaches that you guys took that others can take as well?
The favorite thing I like to do is a demo. It's the most powerful. If you can bring in a small IoT device that you know is vulnerable, show them how easy it is to get a root shell and then pivot through, I think that's the most powerful way to do it. We actually have an IoT lab back at the office, just racks of IoT devices, and you can just go through and hit each one. And I think that's really powerful. You put that up on the board and you show people, this is your home router, and now I'm going through it into your laptop or other device. So that's one of the strategies that we use is the actual demo.
It's like a David Blaine or David Copperfield show.
But it actually works.
When we do our demos on how we kind of break into stuff and get a root shell on this and that, people, and that includes like senior developers and including senior people that I did a live demo on the power outlet thing that I mentioned at the beginning of the panel. I did it at B-Sides Philly, right? So it was like the first edition of B-Sides Philly, and I was invited to the talk there, and I was doing it. And surprisingly enough, the whole audience were like hardcore hackers. Like all of them were red team, all of them were pen testing, all of them were part of these companies that were doing pen testing. And then this guy comes to me and says, "This is so awesome. I'm going to do this. On my next engagement, I'm going to buy this power outlet and I'm going to gift it to the head of HR of the company that I'm targeting." And then, bam, I'm in that guy's house, right? So whenever we're doing the demos, as Eric said, these have so much of an impact. It's like magic, and then people want to know how that magic is done. And when you show them how easy it is to do that magic, the trick in it's insane. The effect is exactly what you would want. And personally, I'm hosting webinars in which I'm doing the magic tricks, and then people are more aware. I'm not doing them periodically. And also, I'm encouraging our InfoSec team to do military drill sort of engagements, right? So non-programmed, they're not going to happen when you expect them to happen. But if we kind of manage to get your domain account, that means somebody in some place needed to do something a little bit better, right? So I encourage our InfoSec team and our red teams to kind of engage, trying to compromise assets in a drill, military drill kind of style.
Yeah, we would do a lot of. I mean, as a CISO, one of the biggest things you have to do is you have to advocate as to what cybersecurity is doing for the company, and you got to get the employees to kind of accept you into the culture of the business so they can see the value that you're bringing. If especially if you want to get budget and get resources and be able to do things, as a CISO leading a security team, you can't be in the back room. They need to see you visibly. They need to know who the team members are. They need to know what you're doing and how you're helping the company. We do like lunch and learns where we bring people together, and sometimes we may be doing a lunch and I'm just briefing you on projects we're doing for the next 6 months, or sometimes they come in and the lunch, I've got a local neighborhood FBI agent who's doing a threat briefing and kind of filling you in on the latest stuff that we're seeing, business, email compromise. Or, I'd have a bunch of my guys, we do a lunch and learn, and we got Raspberry Pis. And we're sitting there with a bunch of Raspberry Pis during lunch, and we're showing them the crazy things that you can do with this little box. Yeah, and I'm explaining to them, oh, by the way, there's a bunch of really cool stuff here that your kids can go ahead and do. And they can learn Linux, and they can do this, and there's games in here for them. And by the way, this can start a career in STEM for them. And they're like in 5th grade or 6th grade. But also, by the way, you can use this to do this, and all of a sudden you take control of the lights for the floor that you're on, or you go ahead and you take over, one of the whiteboard projectors, and they're like, hey, what's going on with that board? And then they realize you're doing it, stuff like that. You kind of show them just enough, kind of a glimpse behind the curtain, and just explain this is small potatoes compared to what you can do. You need to be aware of when you have interconnected devices. Anything's a target once you connect it. And then, and so when they kind of see it at work and, and you're chatting about it, and then you pivot before the lunch is over with, and you say, oh, by the way, this applies at home too. Those smart TVs you have, that PlayStation that your kids are using, and you kind of start walking them through that, and you kind of see lights coming on. And I know I'm doing good, because 2 days later, I'll have somebody come and talk to me and say, hey, at home, my home network, my kids downloaded something, and now our home computer is doing this. Now I know I got them, and they're trusting my team because they're asking me to help them with something at home.
Yes, that's definitely great. I'm definitely feeling the lunch and learns, because at ISC we do, I guess, what we call fire talks, where anyone at the company could, come up during the lunch hour and talk about what they're doing, right? We usually, have, 3 a week, and where analysts can come up and say, hey, I found this really cool vulnerability, I exploited this, and everybody's engaged. People are asking questions. And we also have, more of the, I guess, non-technical folks also get up and do fire talks, right, about what they're doing. And it's also really, really cool and entertaining as well. So definitely lunch and learns are definitely a good idea to have if you are thinking about doing it, pilot it, see where it goes, but definitely a good source of information.
Well, we actually thought about doing like fish tacos and beer after work, but we found that they had a liability issue about paying for the beer. And then they got upset with us when we did it once after work, and we were actually playing around with the bar area that we were in. We could see all the cash registers and stuff, with the devices that we were playing with, and we were told to stop. So we had to keep it at one time.
It's pretty cool. Cool. So we are a few minutes past our cutoff time, but before I'll end this panel, I would like to give each of our panelists a few minutes to give any last regards or statements that they may have, and provide the community with any additional value. I guess, Eric, do you want to go first, and then you can follow up with Gary and then Dre?
Yeah, sure. I'll do a shameless plug for 6th Gen. We're also a consultancy if you need help with your security. We also have the IoT range that we built to train for the DEF CON CTF, and we're going to be releasing that as a rentable product. If you want to train up your team on IoT stuff, contact us, and we'll have that for you.
Sorry, I was trying to unmute there. I'm not a consultancy, but I will say from a community perspective, those people that are listening, those people that are hearing this, get involved. Help with the IoT Village and the other types of villages at DEF CON. Help at B-Sides. Write articles. Submit content to peer lists. Get involved in the community. Talk to other people who are wanting to make a career change. We need diversity. We need a lot more women and a lot more of other people. You know what I'm saying? I mean, it can't just be the same people coming into our community. We need diversity to survive. The technology is changing. Everything is fast moving. And, I talk with vets a lot that are transitioning, and tell them, you still want to serve, you still want to be involved, you still want to do something that's fascinating and everything. Cyber's all of that and more, And so I tell people, you are if you love cybersecurity and you're working in the field, you're a walking billboard for why it's an awesome career field. Talk to people, and at the same time, if you're already working in the field and you're having problems and everything, you've got a community to be able to reach out and talk to people and ask for help. Don't go it alone. Don't deal with the stress and the issues that you're having. You've got people to go ahead and talk to, whether it's on LinkedIn or whether it's, in Slack. There's plenty of groups and everything. You don't have to go ahead and be by yourself. We're all in this together. We're here with each other. We got events like this and everything. So, definitely take care of each other, especially right now. There's a lot of stress and a lot of stuff going on, with our teams.
Okay.
Very, very quickly. First of all, building CTF platforms, awesome. Eric, nice. Yeah, always a good thing, because this kind of fuels. Commercial or non-commercial, it still fuels the knowledge pool needed to grow the community, the InfoSec community. Second, Eric, what you're doing is equally, if not more important, because all of these things put together kind of make the whole knowledge pool more relevant to everybody else. Contributing is key, definitely. I would want to say that hacking IoTs is easier than hacking Windows machines. Really, I mean, if you're familiar on how to reset your root password by hijacking the Grub or the Lilo bootloader, you can literally do the same thing over serial with IoT. If you can find the serial pins on an IoT, you can hijack the bootloader and get access to the file system the same way you would kind of hijack Grub or Lilo. And that's just a sneak preview on how easy it is to hack IoT. Okay, and then, I mean, there's definitely not enough research being done on IoT security. We've been trying to kind of push towards cloud IoT security in the past 3 years, simply because it's much difficult to see those vulnerabilities unless you look at them. And if you try to look at them, they're very easy to spot. And on top on what Eric and Gary have said, I just want to add more responsibility from the vendors as well. Because we've been researching vulnerabilities and we've been pitching them to the Amazons and to the Googles and to the Godzillas and all the other companies. Amazon replied, awesome. So, I mean, the fix, okay, 2 months, okay, but at least they were in contact with us. However, there were a lot of other companies that some of them didn't even reply to our emails. And the vulnerabilities were like insanely dangerous across the entire world because they have like really popular products. So I would want to add this besides what Eric and Gary have said, right? So a call toward companies to have a security contact, a call towards companies to have this a vulnerability disclosure program through which we can report vulnerabilities so we can get them fixed. So that's my take.
Good stuff. I think we're running into our next talk, but I will leave everyone who's viewing with a bit of information that we have about our village. We have various labs going on. We have CTF. So if you're not, on our Discord server, please join that. If you need help signing up for that, visit us on Twitter, IoT Village. You can message me directly on Twitter, LinkedIn. Find me, Drew Branch, and I will definitely hook you up with some information. But I would like to thank my panelists for joining me today. Definitely great insights were definitely shared by each and every one of them. So with that, I will bid everyone good day. See you.
Good night in Romania. But
good night. Yeah.
Bye.
We think about IoT Village as a movement. These devices are being adopted so rapidly that security is not effectively being baked into the development and deployment of those solutions. That puts consumers at risk, that puts businesses at risk, that puts governments at risk. And what we're trying to do is to galvanize a community around solving that problem.
Every time somebody hears IoT, they immediately think, I don't want this in my house. But as time goes by, that choice of having something in your house or not is not really there.
You can walk in the village, you won't feel like you're asking a dumb question, and you'll still walk away learning something no matter what your skill level is or knowledge.
IoT Village provides an opportunity for people to experience security in a very tangible, very real way.
So what ends up happening is I can kill Lisa right now. She's being smothered. She's flatlining, patient monitor's going nuts, she's dead. What's going on at the nurse's station? She's fine. What I'm doing right now is we are replaying recorded data of a healthy patient. So this patient monitor is something you'd see in every hospital room in America probably. The IoT Village seeks to raise awareness of IoT security. We want consumers to be able to make informed decisions, and we want manufacturers to improve their security.
So we put a lot of work into the security on the Bird 2, and we wanted to put it in front of the DEF CON community and see what people were able to do with it. We've learned stuff about our tech that we didn't previously know, and from my perspective, that's phenomenal because we have a really talented team internally, but when we can be educated by people external to the company, it's a big, big win.
We really want to show that we very much welcome the work that security researchers do, and even though we work in a world, the medical device world, that's not as accessible to the people that work in this space, we really value the input that researchers have. We want to show that we love for them to work with us on medical devices and what they can find in it.
Security is a mission-critical part of being a pioneer. And by participating in this, they're able to address some of the challenges that are introduced through innovation.
Building a contest to challenge hackers, at the world's biggest hacker conference, if these guys didn't know what they were doing, this room would be empty.
So IoT Village is awesome. Unfortunately, a lot of hackers work in these small groups. They don't really share a lot of information because they kind of want to monetize or capitalize off of the information that they have. So being here in IoT Village gives us an opportunity to talk to a bunch of other hackers that we wouldn't normally talk to and share information and kind of come together as one.
I think it is the best thing since sliced bread, personally. This year we're here at DEF CON helping run a hands-on lab, IoT Hacking 101. How do we get people involved with this? Because it might be intimidating, right? Walking up into a big CTF at a big conference. The idea is that we handhold them all the way through from the basics of firmware analysis right through to discovering a bug and popping a device or two.
I just connected over Netcat. There was nothing fancy, no authentication, anything like that. And this number here is your authentication token. It's a serial number on the device. That's what they're using for authentication. So what we're doing is that we're showing people how we find vulnerabilities in embedded devices. Specifically, I've been targeting NAS devices, and I've been showing how we find vulnerabilities, develop an exploit for it, and exploit it from the attacker's perspective.
IoT Village is the face of IoT security worldwide. They're probably the most preeminent brand when it comes to dealing with IoT security. We have expertise, they have expertise, and we feel that it's more than just a sponsorship, it's more of a partnership in which we share stuff with each other. The visibility that you get from all of these conferences is an amazing thing.
It's only going to get more and more relevant, and the devices are only going to get more and more prevalent. And so I think it's just a great interactive, hands-on experience for people to come and get immersed.
We know that these security challenges that are inherent within connected devices, they're not going away on their own. We're able to make these challenges come alive, to become real, to be tangible. And when we do that, we enable people to participate in being part of the solution.
Okay, hello everybody, I'm Ilya, and today we're going to be talking about emulating IoT firmware and malware with Docker and QEMU. I'm calling this new tricks for old techniques because this is the same stuff that we've been doing a long time to emulate devices. It's just new tricks to do it in ways that are a bit easier to work with. I'm going to give a bit of background on why I started doing this research and where everything came from. Originally, we were intending to do this to create a CTF that would be all IoT target devices, and each team competing in this starts off with a C2 node and a single infected bot, which they then use to scan networks and attack other targets. At the end of the 24-hour period, the team with most bots wins, and the end result of this attempt at building the CTF was a working proof of concept for putting together a IoT botnet lab. The CTF itself is still unfinished, but the research here that I think is valuable to share is just how all of this was put together, because it has more applications beyond just building a CTF for a game event. And yeah, one of the major technical challenges that we had established from the outset in building this project was any malicious traffic stays within the subnet that the botnet lab is running in. So we don't want to be accidentally sending out malicious traffic from our botnet lab to the internet at large. Here's a quick roadmap for how we're going to break down this talk. The first section is a quick introduction to basic concepts, user space simulation, multi-arc containers. The second section is the real meat of it, where we're going to go through some case studies to demonstrate how this proof of concepts works, to demonstrate these techniques. We'll discuss some of the applications this has to vulnerability research, exploit development, other security-related disciplines. We're going to discuss the advantages and limitations, and also some ideas for further work and research and to continue from where I've gotten things so far. The purpose and motivation for this is basically that Docker makes it really easy to share appliances as container images. Basically, I can just, if there is a device that I want to emulate and somebody else has already built one, I can just Docker pull that thing, Docker start, and give it whatever flags it needs, and it comes up and running. So one person does the work to build an image of some vulnerable device, publishes it on the Docker Hub, and then anybody who wants to research it can just Docker pull that thing and it'll run on their machine. There's no need to have like KVM and QEMU or doing any of the old-fashioned kind of techniques that is required to set up a working emulation environment. The IoT security is also notoriously poor. So one of the main things that we want to emphasize here is being able to research malware and also research firmware, any kind of software really that is running on non-x86 hardware. We want to be able to make it more accessible for people to do research on these things and to improve the state of security, and also to sort of work against the fact that attackers have a lot of advantages in this domain, because as we all know, a lot of these vendors don't even think about their security. Even if they did, the users aren't going to update the firmware. So yeah, this is a domain where a lot more research needs to be happening, and anything that can facilitate it, I think, is worthwhile to look into and to share. So let's talk about containers real quick. They're often described as being like lightweight VMs, but it's important to understand that they're not actually virtualizing anything. They're sharing a kernel with the host operating system, and a container is really more just like a CH root that has some extra restrictions imposed on it due to Linux kernel features like namespaces and C groups. So a container image is built from a Docker file. The Docker files just have all the instructions that are executed by Docker in order to build the image of whatever application it is that you're trying to bundle. Essentially, this is just like a tarball containing a snapshot of the root file system, and there's multiple layers on top of it. So you can easily extend and customize any Docker image that you find on the web. And here's just a quick illustration that shows how Docker images look. So like you have a Debian one, and then on top of that you've installed Java, and then on top of that you've installed Tomcat. So this is what it is meant by layering the things. The base image can be whatever you want: Alpine, Linux, Ubuntu Linux, Debian Linux. There's all kinds of options you have out there for base images, and then you can put whatever software you want on top of it. The important thing to see here is also it's all sharing the host kernel. So this is the typical usage of a Docker image, very basic stuff. I'm just including this in case some people are not familiar with Docker or haven't really worked with it in the past. This first example is just a standard invocation of a Docker container. So I'm just running bash in that container, showing the Debian version, voila. And then this is a sneak peek at what a multi-arch container looks like. So you can see when I run the command uname-m within that container, it says it's a MIPS machine, but my workstation is in fact a x86 64 machine. So what we see here is it is in fact possible to make a container think it's running on a hardware that it actually isn't. And it is because of QEMU that this is possible. Most of you have probably worked with QEMU before. Most likely, though, you've worked with QEMU in what is called the full system emulation mode. This is usually how it works also when you're running QEMU alongside a kernel hypervisor like KVM. And you're typically managing QEMU instances through something like libvirt or virt-manager, which is like the graphical front end for it. So these are all familiar tools that have been in our toolbox for a really long time. In the full system emulation mode, we are booting the entire operating system, which has its own kernel, RAM disk, init file system, everything. It goes through the exact same process as if it was booting a real hardware device effectively. However, there's another mode that QEMU supports, which is the user space emulation. And this is useful for transparently executing cross-compiled binaries on your workstation. And for our purposes, it is this QEMU user space emulation that we're going to be interested in. So what is this QEMU in user space? This works by basically doing just-in-time translation of emulating the target CPU architecture by it translates the machine instructions. So if it has some MIPS instruction, QEMU knows how to translate that into x86. If there's some MIPS syscall being executed, it knows how to translate that syscall into a native syscall on the host that it's running on. So there's no virtualization happening here. It is just like JIT translating the syscalls and machine instructions. It is important to note that there are many IOCTLs that don't work in user mode, and there are also some system calls that don't work. Usually these are if you run into situations where some device that you're trying to emulate in QEMU user mode doesn't work for one of those reasons. Usually it is pretty easy to patch that in QEMU. It is just new IOCTLs and system calls are being introduced to Linux kernel all the time, and the QEMU maintainers sort of lag behind that a little bit. And it's also important to note, and we'll discuss this a bit more later on, that the host kernel is, all of the system calls are being passed through the host kernel. We're not emulating a full system. There's no virtual kernel working here. And this has some ramifications if you're doing exploit development testing, for example. The interesting question is, how does the operating system know which QEMU interpreter to use for a given binary when it is doing this transparent user mode execution? And the answer lies in the, I'm going to pronounce this as bin format MISC. Maybe I'm butchering it. Who knows? Anyway, this is a file that lives under the prossysfs hierarchy. And so when the operating system is executing a program and it has this bin format MISC table populated, it takes a look at the ELF section header in the binary it's trying to execute, checks the magic number. If that magic number corresponds to one of the entries in this table, then it will use the corresponding interpreter to execute the binary rather than just trying to execute it natively. So you can see here the QEMU MIPS register. It's enabled. The interpreter is user bin QEMU MIPS static. And there's flags, offset stuff all set there. The magic number is the magic number for MIPS executables. So now we're ready to talk about the multi-architecture containers. This is basically a combination of QEMU and this QEMU user mode and Docker. The first thing to make sure of is QEMU's got to be installed on your host system. This is accomplished by the first shell command up here. That'll install the packages you need. If you're not on a Debian-based system, then I'm sure that translates pretty readily into a Yum or whatever package manager you prefer. The multi-arch image repository on Docker Hub, it provides a script that will populate your bin format MISC directory with all of the necessary entries for setting up the emulators. So this is kind of weird because it is a container that you're executing, but you're putting it in privileged mode, which allows it the ability to do stuff on the host that it normally is not allowed to do. In this case, it is writing entries into proc, sys, fs, bin format misc. But this is a very easy way to set up the host machine for running multi-arch images. And we can see in this last step that indeed it does work. You just do the Docker run on an ARM64 V8 image, and you have the uname.shim. Indeed, it thinks that it is running on an ARM machine. There's a lot of available base images from the repository here. So you can see that there's Fedora, CentOS, Ubuntu, Debian as the main ones. There's BusyBox and just even the smaller one that's like bin.true for a variety of architectures. So whatever your preference is, there is a base image for doing work on, in Docker on a architecture that is not x86. And you can see the various architectures that they support here. So why is this useful for IoT security research? Well, I mean, first we can just execute cross-compiled binaries on on our workstations without any overhead. This is useful in a variety of scenarios, and that's not even limited to IoT research or security research. That's just useful for anybody that works on multi-architecture software. Another thing this allows us to do is debugging cross-compiled binaries without setting up a whole CH root or configuring a virtual machine for it. You can also do this for rapid prototyping of shell code or various payloads that you want to make sure are going to execute on a particular revision of a target CPU, or maybe you've ported some shell code from ARM to MIPS, and you want to make sure that it actually works. Then you have a very easy, rapid testing cycle right there, easy to use. We can also set up honeypots to get samples of malware that's targeting non-x86 hosts out there in the wild. So just a lot of imaginative use cases you can feasibly come up with for this. I've listed only a few here. So now we get to the real meat of this, which is emulating IoT firmware in Docker. The first challenge with emulating firmware is oftentimes getting the firmware. When you're lucky, or if it's a particularly well-known device, the firmware is pretty often directly available on the vendor's website. And a lot of vendors will even keep up the obsolete firmware versions that have known vulnerabilities in them, which is really sweet for the thing that we're trying to do here. There's also a scraper module that is built into Firmidine, which can fetch a ton of firmware images. Just like you let that thing run overnight, and you've got tons and tons of gigabytes of some of them useful firmware images. And basically, if you run out of luck searching the web for the firmware you're interested in, then you have to get creative. Maybe you need to Wireshark and DD and intercept the actual firmware being updated from a physical device. Or there's a lot of techniques that I'm not going to obviously discuss here, but you have to get creative if you can't just find the firmware easily on the device or from the vendor's website. In our case study, we're going to be looking at two specific devices, the Netgear WNAP320 at the version 2.0.3, and the D-Link DUR 866L, and there's a long version string. So yeah, these I just got from the vendor's website. And Firmidine is the tool that I use for extracting the root file system out of the binary blob that I downloaded from the firmware vendor website. Firmidine is awesome, and you can use it to set up a full system emulation QEMU environment that has all the peripherals. It infers the network setup. It does a lot of the tedious work for doing the whole QEMU full system emulation setup, but we don't want to do this. That's not our goal here for today. All we want to do is extract the root FS and then put it in a Docker image and let Docker do the execution. So this is a screenshot from extracting the root FS on that Netgear one. This is the top highlighted part here is the command I ran inside the Firmidine container to extract the Squash FS out of it. And then you can see in the second highlighted part down here, I get a ELF. I guess it doesn't say that that's an ELF. But I get the root file system out of here. And I pass flags of don't extract the kernel or anything like that because we don't need it. We're going to be running this in Docker, and Docker, of course, does not allow us to use our own kernel. And then now that we have this firmware.tar.gz that was extracted from Firmidine, we can start writing the Docker file to create an image for this device. And I've just pasted the Docker file right here into this slide. The first line is just saying I'm going to refer to this multi-arch Debian dev bootstrap MIPS Buster Slim as QEMU. You can think of this as like a Python import statement, like import JSON as JSON or something. And then the actual build steps happen in the next line. So we start from scratch, which is a completely empty Docker image. There's no content in the scratch base image. You could, for example, throw a statically compiled hello world.c program in there and it'll echo